Hello and welcome to my beginner's guide to building a PC, where I'm going to be showing you how to put all the parts I've got in front of me together today to come up with a fully working PC. Not only that, but I'm going to be explaining each step in a lot of detail. I'm going to be assuming that you don't know anything about PC building, and rather than give you a guide that you can follow from start to finish, I want to explain why I'm doing each of the steps. So should you want to deviate away from any of them, you're going to understand how to do it. And I'm going to make a few recommendations for each of the parts of where you can go up or down, depending on your budget and depending on your needs. As well, I build probably about 25 PCs a year, so I know what the common mistakes are, and I'm going to be pointing all these out today so you can avoid them. So at the end of the video, when you press that power button, you've got the best chance of your PC booting without any problems. Okay, let's get started. So the first thing to pick is your case, and I think the most important factor when picking your case is the size. This depends on your own personal preferences and what type of builds you want to do, and as well how much space you have in the room or on your desk for a PC case. And they range from really small mini ITX cases to full tower cases. If you're building your first PC, probably a good middle range is to go with a mid-tower case like I've got here. And the mid-towers come in more compact and, like we have got here, a fairly generous mid-tower case. And the reason I'm recommending this, the mini ITX cases where a lot of your components are squeezed in, the components are generally more expensive, the building process is more difficult. Where if you go with a mid-tower case like we've got here in the Landcool 216, you shouldn't really have any difficulty fitting your components in. You're going to have a better range to pick from, you're going to have more budget options. So for a first build, this is a perfect choice of a case. The Landcool 216, which I've picked here, was my case of the year for 2022, so I can definitely recommend it. And the other thing then when you're picking your case, once you pick the size, is pick a case that you like the look of. Go on to YouTube, check out the reviews of the cases, make sure it's got all the features that you want, make sure it's good in terms of noise levels. If it's got included fans, make sure they look good and make sure they run nice and quiet. The last thing you want to do is buy a case based on the fans and find out that they're all really noisy. So I've done the hard work for you here. This is a really nice case from Lian Li. It's well priced, it's got a lot of good features, and that's the reason I've recommended it for today. But should you want to go with a slightly different case, you should still be able to follow along to this build guide with a few changes. So the next thing for us to do is to pick a motherboard, and there's a lot of factors that come into play when picking a motherboard, but the first thing I want to take a look at is the size. So the motherboards range from the largest in eITX, down to ATX, then micro ATX, and then mini ITX. The eITX boards are generally high-end boards only, and in terms of their size, in terms of the actual length, they're the same height as an ATX, but they actually extend further over to the side. So they're a wider board, but the same height as an ATX board. Comparing then the micro ATX to the full-sized ATX board, you'll notice that they're the same width, but in terms of the height, the micro ATX board isn't as tall. And then we've got the mini ITX board, and it obviously isn't as tall and isn't as wide as a full-sized ATX board. In general, you've got less choice in these type of boards. They tend to be a bit more expensive than a standard board, and being smaller, you're getting less features on it. If you look at the PCIe slots, look at your slots for M.2, and then if we turn the boards around, if you look at the I/O, you're going to have less ports on these boards, which is the reason I'm recommending, if you're going for a mid-tower case, go with a standard ATX board, because you're going to have a bigger choice. One temptation I would avoid is putting a micro ATX board in a full-sized case. And the reason for that is when you install it, it's going to install in the same position, but you're going to notice there's going to be a big gap at the bottom, and then you're going to have all your cables from the bottom of the case running up to the headers at the bottom of the motherboard, and they're going to look really, really untidy. And this is one of those common mistakes I see a lot of new builders make. These boards tend to be quite cheap. People pick one of these up instead of one of these, thinking it'll do the same job, and the cases will accommodate, the case that we've got will actually accommodate all four of these boards, but I would say only the full-sized ATX and the ATX board are actually going to look good in this case. This board, you might think looks good, but once you plug in all the cables and they're running up the case to the motherboard, it's not going to look good anymore. So next thing to consider is, do you want to go with AMD or do you want to go with Intel? Because the motherboards aren't going to be interchangeable. If you want to go with an AMD CPU, you're going to have to get a specific type of motherboard. If you're going to go with an Intel CPU, you're going to have to get a different motherboard. And these are the two strict equivalents, one for AMD and one for Intel. For me at the moment, this is a guide for building at the start of 2023. I would go with an AMD CPU personally if I didn't have any parts and I was setting out from new. And the reason for that is this is the first motherboard for the M.2 socket. So the advantage is if you go with this type of motherboard, should the CPU get upgraded each year, you're going to be able just to drop a new CPU into your motherboard and get that improved performance. The LJ1700 socket that the current Intel boards use, this is going to be the last year of this particular socket, and there's going to be a new socket coming either later at the end of this year or the start of next year. I don't think the date has been fully confirmed just yet. So the current 13th gen of CPUs is going to be the last lot of CPUs that you're going to be able to drop into this board. If you have got some DDR4 lying about, there is certain boards that you can get that will work with DDR4 on the latest 13th gen CPUs. Whereas the current generation of AMD CPUs, you're going to be using DDR5. So it makes sense if you don't have anything sitting about, this is what I would recommend buying. The advantage of this, if you've got some DDR4 lying about, you don't actually have to go with the latest generation of board. The 12th gen CPUs and the Z690 motherboards and equivalent chipsets will run with the 13th gen CPUs with a BIOS update. So there definitely is cheaper options to get into a PC with Intel, but you're going to have less forward compatibility at the moment. So for today's build, I'm going to be showing you how to install one of AMD's latest 7000 series processors. So assuming we're going with an AMD board, the next thing to decide is what chipset we want. So the highest end chipset is the X670, and the E is the highest end, it stands for Extreme. The more lower end chipset is the B650, and again it comes with and without an E, E standing for Extreme, and it is the better version. So you've got a choice, and a motherboard, this is one area you can really overpay for. The same CPU running in both these motherboards, there's going to be very little difference in terms of performance out of the box. The big advantage of the more expensive motherboards is, one, they look good, they tend to have more features, and as well, if you're planning to overclock them, you can get the most from your CPU. But in general, you're really talking about a few percent in terms of difference for actually hundreds of pounds in difference in terms of cost. So my advice to you is check out the motherboard reviews, find a good one, check and see if the cheaper boards, you like the look of them, and they cover all the features that you want, and then pick a board that way, rather than just spending all your money on a really expensive motherboard and having to go with a lower quality graphics card. Because actually, if you're building a gaming PC, going for a more expensive graphics card and a budget motherboard is quite often the better way to do it. And then the final thing to consider is brand. If you're going for a particular brand of PC, for example, if you're going with an Asus graphics card and Asus motherboard, the one RGB package is going to be able to control everything. Whereas if you're going with lots of different hardware, you might need one RGB package for your graphics card and one for your motherboard. So it's just worth factoring that in. People tend to have brand loyalty. There's one particular motherboard they like. I use motherboards from all brands in this channel, and in general, they all work fairly well and fairly similarly. So I wouldn't go with that as a particular preference. Pick something that you like, has all the features that you want, and isn't going to break the bank. So then we need to choose our CPU, and again, it's a choice between Intel and AMD. And if you start off by comparing the core count, you might get confused here because they don't work the same. AMD just go with all cores the same. Intel have this hybrid architecture where they have P cores for performance and E cores for efficiency. So the P cores are the big cores that do the heavy lifting. The E cores are the efficient cores, are the ones that do more background tasks on the PC. So you might look at this and think this has got more cores than this, and this is the one I should go with. So what I would suggest doing is, what do you actually want to do with your PC? Is it just for gaming? Is it productivity as well? All those factors are going to determine what sort of CPU you should go with. So what I would again suggest doing is going over to the benchmarks. comparing one CPU with the other for each of the tasks that you want to do, and see is it really worth spending that extra money to go up on the CPU. In general, with something like this, 6-core tends to still work pretty good just for gaming. If you want to do more productivity stuff, you generally want to go up on the cores. So for the CPU for today, I'm going to be installing the Ryzen 9 7900X, which is a 12-core CPU. It's a pretty good CPU in terms of productivity. It's more than what you need for gaming. But again, if you want to go with one of AMD's other CPUs, installation will be exactly the same as what I show you in this video. So you'll be pleased to hear we're now ready to start putting some parts together, and I'm going to be showing you how to install a CPU on the latest AMD and Intel platforms. So the biggest difference between these boards is the socket. You can't interchange them, so if you've got an AMD CPU, you need to install an AMD motherboard, and if you've got an Intel CPU, it needs to go on an Intel board. The sockets are both LGA sockets, so they will have pins in the socket and no pins on the underside of the CPU. And this is a change for AMD. Previously, you would have had the pins on the underside of the CPU and no pins in the socket. And the big advantage is with this new platform, I think it's much easier to install. So another big difference between the boards, if we take a look at the AMD board, you'll notice that we get mounting clips for the stock CPU coolers pre-installed. It has a backplate on it if we turn the motherboard over, and you can't actually remove this backplate, which is again a change from the previous generation of motherboards and CPUs. Comparing this to the Intel boards, you generally don't get a backplate with the motherboard, you just have holes for mounting a backplate which needs to come with your CPU cooler. And Asus have two different types of holes here. The outer holes are for LGA 1700 coolers, and the older generation of LGA 1200 had slightly different spacing. So Asus have two holes here, so you've got an older cooler that has LGA 1200 support but not LGA 1700 support. You can still mount it. My advice is most coolers now will have LGA 1700 support, which is what this socket is, and I would try and get the correct bracket because you get improved mounting and improved cooling using the correct bracket. But this is a way, if you only have an LGA 1200 compatible cooler and you can't get a bracket for it, you can still install it on this motherboard. The other thing you'll notice is I have the motherboard resting on a box, and the reason for this is the back of the motherboard is sharp. You've got all these pointed things, and if you have this on the table and move it up and down, it will scratch your table. So it is generally good practice to pop it onto the back of the box where you're not going to scratch up your table. Okay, first step in installing our CPU is to open the socket cover. So this lever here, we need to push it down and out to free it up. And then we're going to lift it up towards the middle of the motherboard. In this position, we should be able to open the socket cover by bringing it up towards the top. And then you take a look at our socket, you'll notice we've got lots of pins in the socket, and we need to be really careful with these pins that we don't touch them, or be really careful when we're putting our CPU in that we don't damage them, because if we do, that could be the end of our motherboard. And you'll notice that the socket cover has this black plastic protector on it, which is designed to protect the pins when you don't have the CPU installed in the socket. So the other thing I want to point out, if you look at the top left-hand side of the socket, you'll notice it's got a triangle on it. And this is an orientation mark, so we're going to have to line this up with a similar mark on our CPU. So we put the CPU in the socket in the right orientation. So this is our CPU, and if we look at this top left corner, you'll notice it's got a little triangle on it. So we're going to have to install our CPU into the socket the way I have it orientated now, which is with the text the correct way up. And with the latest generation of AMD and Intel CPUs, it's really straightforward. You just put it into the socket the way the text is installed, so it's up the right way. With the older ones, you had to install them slightly on the side, so it was always difficult to get the orientation right. The easy way to remember it, you can line the triangles up, or just put it in with the text the correct way up. Taking a look at the back side of it, you'll notice we've got loads of gold contacts on it, and importantly, I'm holding the CPU by the sides. I'm not touching the underside because I don't want to get anything on that and prevent it from working. So next we can set our CPU into the socket with the text the correct way up, with little notches at the top and the bottom of the socket which line up with notches in the CPU and help it get into place. And once you've got the CPU in the socket, you want to just slightly rock it from side to side just to check it's properly seated in the socket. Now it's really important you don't go pushing down, because if you don't have it in right, you can actually damage the pins in the socket. So we can see that's fully in the socket and it's sitting nicely. So once we're happy with the CPU in the socket, we can simply close the cover down. Then what we're going to do is pull the lever back down. Now, as we do, this black bit of plastic will pop off, so don't be alarmed by it. So we're going to push the lever back down and then pop it in underneath the socket. And you see why I warned you about this. If this happens when you're doing this for the first time, it can be really worrying. Now, what we're going to want to do is pop this into the motherboard box so we don't lose it. Whenever we take the CPU out, it's really important that we put this back on to protect those pins in the socket. So I'll show you how to install a CPU in the Intel board. So again, we're going to push the lever down and out, but this time we're going to bring it up towards the top of the motherboard, and the socket's going to open the opposite way up towards the middle of the motherboard. So in terms of installing the CPU, it's exactly the same. Make sure we don't touch the gold contacts underneath. And in terms of orientating the CPU in the socket, we're going to install it with the text the correct way up. So again, we're just going to set the CPU into the socket, line it up with the notches at the top and at the bottom. And again, once it's in, a little wiggle from side to side, checking it's properly seated, which it is. We can then close the socket cover down. I've always found it easier with the Intel boards to actually apply a little bit of pressure here and get the black bit of plastic to pop off before you close the lever. So it's just a little bit of pressure here. Take the black bit of plastic off and again put it in the motherboard box to keep it safe. And then we just need to close the lever down. And that's our CPU installed. So next thing to talk about is storage, and if you're building a PC in 2023, my advice is to use an NVMe M.2 drive if possible. It's the easiest to install. It simply slots into your motherboard underneath the heatsink. There's no additional wires to connect up to it. So in terms of installing it, it's going to be the easiest, and it's also going to give you the fastest possible speeds compared to the other options that we are going to talk about, and I will show you how to install all of them. So in terms of this drive, it's available as an NVMe in Gen 3, Gen 4, and hopefully coming later this year, Gen 5. And as the generations go up, so do the speeds. It is important to say, where are you going to get benefits from these speeds? In terms of, I think, having it as a boot drive for your Windows PC, you're going to get some benefit from your PC booting quicker and everything running smoother if your Windows installation is installed on one of these drives. Certainly compared to a hard drive, and there'd be definitely some advantages over the SATA drive. In terms of installing your games library on it, you won't get that much of a benefit over a SATA drive, but again, you're going to get a massive benefit over a hard drive. And again, going up the generations, you're not going to get that much of a benefit either. Where you do get a benefit from that fast Gen 4 and hopefully Gen 5 drive is if you use your PC for content creation, you'll get a benefit there. And I tend to have multiple Gen 4 drives in my video editing PC at the moment. The other options that you have available to you are SATA drives, and SATA drives come in this 2.5-inch form factor like I've got here, where you're going to have to plug in a power wire and also a SATA wire and connect up to a SATA port on your motherboard. So the connection is a wee bit more difficult. It's going to take up space at the back of your PC and there's going to be some wires running on it. You also get M.2 SATA drives, so importantly, make sure when you're buying an M.2 drive, it's an NVMe one to give you the fastest speeds compared to an M.2 SATA drive. And then the other option that you have is these mechanical hard drives with moving parts in them, and this is a 3.5-inch form factor, but it also does come in a 2.5-inch form factor. And this is the slowest, but it is also the cheapest to buy. So how I would tend to set up my PC is the first thing I recommend at least 2 drives in your PC. What I would do is have a Windows install on one drive, and then if I'm going to be installing a games library, for example, or I'm going to be using it for video editing, I would use another drive for that purpose. And the reason is you don't want to fill up your Windows drive with lots of games, and once it gets filled up, it's going to be less efficient and perform not as well. And the other thing is, if I'm video editing, I don't want all my files on the same drive that has got the operating system on it. So the video editing packaging is bringing in lots of files into the system and sending it out when it's rendering. I also don't want that to be the same drive that Windows is running on, where it's going to affect performance. And in general, my video editing PC, I'll have a drive for my operating system. I'll have a drive I keep my files on, and then I'll have another drive where my files go to when it's being rendered, and that keeps my PC running nice and efficiently. But my recommendation is, if you're building a gaming PC, have a smaller capacity NVMe drive for your boot drive, And again, I would recommend a Gen 4 drive for that at the moment to get the best performance. The price in terms of the generations, there used to be a big jump between Gen 3 and Gen 4, and you used to have to consider one over the other. Was it really worth it? There's not that big of a difference now. And again, there's not that big of a difference between this and the 2.5-inch SATA drives. So in general, I'm always recommending NVMe drives. If for your games library, you won't get that much of a benefit over Gen 3 versus Gen 4, but I would still probably recommend a Gen 4 if you can get it for a reasonable price. So that's the NVMe drives. Where I would recommend some of these other things, if you've got these drives lying about, no harm putting them into your system. If you're buying them from scratch, go for the NVMe drive. The big limitation with the last generations of motherboards used to be the number of NVMe ports on your motherboard. Some of them used to just have 2. So for example, for me, where I like 3 drives at least, I was going to have to use 2 of these and 1 of these, or get an extra card plugged into the motherboard to allow me to add more NVMe drives to it. Now the motherboard that I have has got 5 M.2 slots in it. So again, my recommendation is mostly for these. If you run out of M.2 slots, you can use these and you're going to go down in speed slightly, but I wouldn't use that for your power intensity tasks if possible. I would pick one of the NVMe drives over it. The mechanical hard drives tend to be the cheapest option, but they're also the slowest. So again, it would make a terrible boot drive for your Windows PC. It would make a terrible video editing drive. If you're loading games off it, it's going to take longer for your games to load. So in general, I would use this for long-term storage. So files that you're not really going to need and you want to back up onto. And the other slight downside of this is it is noisy. There's parts moving in it. And actually, I can't leave this powered on in my PC. I do have 2 of them in my main PC, but what I do is I remove the power cable from them. And whenever I want to get files off it, I'll open the back of the PC, plug the power in, and then go into it and get the files off because I don't like the noise off it. So again, lots of options, but the summary is stick with this if at all possible. So next thing for us to do is install our M.2 drives, and this motherboard has 4 sockets. So we've got 1 behind this heatsink, 1 behind this heatsink, and 2 behind the bottom heatsink. Each of the heatsinks are held on with 2 screws, so we'll go ahead and get them removed. So the first thing to point out that the motherboard has 4 M.2 slots. They all aren't created equally. The first clue is the top slot has this really beefy heatsink with a heat pipe in it, whereas a lot of the other slots, the heat sink is not as beefy. So you're going to get better cooling in this top slot. The next thing to do is go into your motherboard's manual and look at the specification of each of the slots, because quite often they will vary from one motherboard to the next. So I've done that, and what I can tell you is that 3 of the slots support Gen 5 speeds, whereas 1 supports Gen 4 speeds. So the one that supports Gen 5 speeds are this one at the top, the 2 bottom slots, while this one here only supports Gen 4 speeds. The next thing is how many lanes do each of them have, how many PCIe lanes, and they all have 4 PCIe lanes. And this is important because, again, certainly in some of the older generations of motherboards, the number of lanes for each slot varies. And then the final thing to factor in is if we install our drive in any of these slots, is there going to be any sacrifices? And yes, there is. This slot here, which is M.2 slot 3, if we put a drive into it, it will actually downgrade the number of PCIe lanes for our graphics card from 16 to 8, basically halving the bandwidth of the graphics card. So this to me doesn't seem like a good idea, so I'm going to be trying to avoid this slot if possible. The final thing to mention is where do the PCIe lanes for each of the slots come from? Some of them will come directly from the CPU, while others will come via the chipset and then go to the CPU. So the ones going directly to the CPU will be the faster ones. And on this motherboard, 3 of the slots go directly to the CPU, and they're this one, and this one. Whereas this slot here, which is M.2 slot 4, goes via the chipset. So putting all that together, I'm going to install 2 Gen 4 drives and 1 Gen 3 drive. So our 2 fastest M.2 slots are going to be this one and this one. So I'm going to put our Gen 4 drives into here. I've already mentioned I want to stay away from this one because I don't want to limit the bandwidth of my graphics card. So it leaves this Gen 4 slot that I've got here, which also goes via the chipset. So I'm going to put my Gen 3 drive into it. So if you're using the motherboard from new, you're going to have some plastic protection here to remove. So all we need to do is insert our drive into the slot at a slight angle and push it in. And then we're going to flatten our drive down. Now, one of the nice things that is just having this motherboard, there's this little catch here to secure the M.2 drive. So all we need to do is push it round, and that's then going to hold our drive in place. Before we return the heatsink, again, if you're using the motherboard from new, you'll have some plastic protection here to remove. And then it's just a matter of lining the heatsink again back up. And then screwing it into place. And it's a good idea to just get this screw tightened slightly before going on to the next one. And then alternate between the two of them till it finally goes tight. Okay, so next we've got our other Gen 4 drive. The one I've installed here is a 500GB drive, which I think is plenty for my boot drive. This is a 1TB drive, which I'm going to use for my video editing. Normally 1TB is enough for a video that I put together for the channel. This drive does come with a heatsink, so one option is we can attach the heatsink onto the drive and then install it in without returning the original heatsink. And because this is a fairly high-end board, it comes with heatsinks over all the M.2 slots. If you get a more budget-oriented board, some of your slots won't actually have a heatsink on it, and having something like this is actually quite useful. In terms of aesthetics, I think it's going to look better just with the original motherboard heatsink, so we'll set it on without the heatsink, slide it into the slot, again flatten it down, and then we'll close the Q latch to secure the drive into place. And then I've got a Gen 3 drive. This is another 1TB drive, and I'm going to use this for my games library. Again, you don't get much of a benefit in terms of loading games from a Gen 3 to the Gen 4 drive, and I've got lots of these sitting about. So it's just a matter of setting the drive into the socket, and again, flattening it down, and then we can close the latch here to secure it into place. In terms of the heatsink, again, I've used this one before, so that's why there's no plastic protection on the back. So we'll go ahead and line it up with the slot. And then we've got our bottom heatsink, and again, I haven't installed drives in these slots before, so we do have the plastic protection still installed, so I'll go ahead and remove it over the drive that we're going to actually need to install it in. And again, another question I'm quite often asked is, even if you're not installing the drive, should you remove the plastic protection? I don't think it really matters. I've installed, for example, I've installed the drive up here. I don't go removing all the other heatsinks to remove this before setting up the PC. But it probably does make sense just to remove it since we're here now. And the worry is people worry about having plastic in a PC that's going to get hot, that it will melt. Again, I've never had issues with this. So I want to show you how to install a drive if you don't have Q latches, but as well I want to point out a very common mistake. So you'll notice we size our drive up. It lines up with the actual hole that we're going to secure the heatsink back on for this drive. So to install our drive, all we would need to do is push it into here and then flatten it down. And when we put the heatsink back on, the same hole that's going to secure the heatsink is going to also secure the drive. Now, these drives do come in shorter lengths, and there is an option to put standoffs into here and here if you've got a shorter drive. And what you would then need to do is use a screw from the motherboard box to secure the drive. And I can show you this down at this bottom slot. We've got a standoff here. We simply insert the drive in. It lines up with the standoff. We're going to take a screw from the motherboard box and then secure the drive into place. And you'll notice that this motherboard's more budget-oriented board, and we've only got a heatsink for this drive at the top. This is the heatsink here. So if we were installing the drive in this board, it'd be better to put it at the top where it would have the heatsink. And actually, if we were wanting to go for a second drive, the one that came with the integrated heatsink, it would work very nicely here. So coming back to my common mistake, and that would be leaving an existing standoff in place and then installing the drive over the top of it. And the problem with this is it can actually bend the M.2 drive. So for example, if you're putting the drive into here with the standoff here, so we'll put the drive in, and then when we flatten the drive down, the standoff underneath can actually be putting pressure on the drive, and I have made this mistake myself in a previous PC build, which is why I'm pointing it out to you here. So if you're ready to install your drive, the first thing you probably want to do is size it up with a motherboard, work out if you're going to actually install with a standoff that secures your heatsink, or whether you're going to have to add an extra one in. If you do have to add an extra one in, and there's another one here, make sure you remove it. So what we would need to do is remove this standoff before installing the drive, and that way we're not going to damage our drive. So next thing to talk about is RAM, and if you're going with a Ryzen 7000 series CPU, you're going to be using DDR5, which is the newest version. If you're using an Intel 13th gen CPU, you could be using DDR5 or DDR4, depending on the motherboard that you go with. There is an option, so make sure when you're getting your motherboard, you check it's DDR4 or DDR5, so you get the right kit of RAM. I think if you're starting out from scratch and you're picking up all your parts, as I've mentioned, I would recommend going with the AMD and DDR5 because it doesn't make sense to me to be buying old hardware that you can't carry forward into the new generations. So there's a few things to factor in when you're picking your RAM kit. So it is available both with and without RGB, so you're going to have to decide, is that something that you want or something that you don't want? Again, you might be going with a build where a big air cooler is going to be blocking the RGB on it, but again, you mightn't always have that build. You might decide later you're going to get an AIO, and when you take it off, you might want to see the RAM and see it lighting up. Another thing to factor in is the number of sticks. The RAM is available in kits of 2 and 4 generally. You can also buy it in single sticks. For most people, I would recommend getting a kit of 2. The reason is it's generally more stable and you're going to get faster speeds. When you go up to a kit of 4, it doesn't tend to run as fast and you're going to have more stability issues. A common mistake is actually, I'll pick up a kit of 2, and if I want to increase it later on, I'll get another kit of 2 and add it in. That may or may not work. And generally, if you want to have 4 sticks of RAM for increased capacity or aesthetics, you should be buying a kit of 4 sticks of RAM that are guaranteed to run together. So even if you pick 2 identical kits from the same manufacturer, it is not guaranteed to work together at the advertised speeds. So if you want a kit of 4, get a kit of 4. You might be able to add 2 kits together. I've done that in the past with DDR4. With DDR5, it may be more of an issue, and I haven't tried doing that yet. So 2 other things to factor in are capacity and speed. So for most gaming systems, 16 gigabytes of RAM are going to be perfectly fine. If you're wanting to go down the more route of content creation, 32 gigabytes is probably where I would start with. And again, to future-proof your PC a little bit, if I was buying one now, I would probably still get the 32 gigabytes. The price of DDR5 recently has come down significantly from where it started. So I think if I was picking up a kit, I would go for 32 gigabytes. In terms of the speed, again, this is improving as the DDR5 improves. So again, price is probably one of the biggest factors for me that I would look at and try and factor in, is it really worth paying for that extra speed? And again, look at the benchmarks and see how much improved performance it gives you in the tasks that you're going to be planning to do with it. Final thing to mention, is my RAM kit actually going to be compatible with the motherboard and the CPU that I'm using? And particularly with DDR5, this is something that I would check out before spending my hard-earned money on parts. And if you go over to your motherboard's website, there is a list of all the compatible RAM kits. It will tell you whether it will run with 2 sticks or 4 sticks and at what speed with each CPU. So before you spend your money, go over to the motherboard website that you're planning on getting and check out the compatible RAM. And if you buy off that list, it should work. So we're now ready to install our RAM, and the kit of RAM that I have got has got 2 sticks in it. If we take a look at our motherboard, you'll notice it's got 4 slots. but we can't just pick and choose which of the slots we put it into and expect it to run at the fastest speeds. But there is a little clue on the motherboard. There's a little diagram here that tells you if you've only got 2 sticks, you're going to want to put it into the second and fourth one along from the CPU. So this one and this one. That'll allow the RAM to run in dual channel and will give us the best speeds. So we need to open the clips on the slots that we're going to install it into. So it's just a matter of pushing here and here to open the slots up. Some motherboards there will be a clip on both slots, so just check before you insert the RAM. So next thing for us to do is to size the RAM up in the slot and make sure we're going to put it in the slot the right way round. In general, the good end of the RAM faces out towards the end of the motherboard, whereas with the end with the label on it faces towards the CPU. Although I have seen RAM kits as the other way round. So all you want to do is there's a center marker here, line the RAM up to the slot, and what we can see is this way round looks right. If I turn it this way round, it won't actually go down into the slot. Where there's a little gap in the RAM and where this little silver bit on the motherboard is, means it won't actually insert into the slot. But had you tried to push the RAM down in this orientation, you can actually damage it. So we'll put it around the correct way, line it up with the slot at the top, and then we're going to push it down gently. Once we've got it lined up nicely, it's just some firm pressure to the top of the RAM, and you'll hear that nice satisfying click telling you the RAM has been installed correctly. And you'll notice the clip on the top has now closed. For our second stick, it's just exactly the same process. Once we're happy it's lined up in the slot, some firm pressure, and the RAM will click into place. So another common beginner's mistake is thinking that DDR5 and DDR4 can be used interchangeably. They can't. Some people will think they've got DDR4 sitting about, they'll get a new DDR5 motherboard, put their DDR4 into it, and later on upgrade to DDR5. This will not work. The gold connectors at the bottom, the spacing is different. So DDR4 must go into DDR4 motherboard where the spacing will fit, and DDR5 must go into a DDR5 motherboard. They cannot be used interchangeably. So we've got one more step to do before we put the motherboard into the case, and that is install the brackets for our CPU cooler. And it isn't going to use the stock brackets. And in general, I would recommend at least putting the bracket for the CPU cooler on if you're going with an AIO. If you're going with an air cooler, I would generally install the whole air cooler onto the motherboard before setting everything into the case. So for us on the AMD socket, we need to remove these stock clips, and they're each held on with 2 screws. So whatever you do, don't throw these away. If, for example, you want to change your CPU cooler in the future or sell your motherboard, you're going to need these. So the best place to keep these is in the motherboard box. So all we need to do is screw one of these brackets onto each corner. So I'll also show you how to install an Intel board. You'll notice that we don't have a backplate and we've just got these 2 holes. The inner holes are for LGA 1200, which was an older socket, and the new ones are the outer holes, the LGA 1700, which is what this socket actually is. ASUS have just put dual holes to make it compatible with more CPU coolers. And the bracket that we have that comes with our AIO supports both of these standards. So the pins pushed all into the middle. If we line it up with the back of the motherboard, it's going to go through the inner holes for LGA 1200. If we pull all these to the outer setting, it's going to be LGA 1700 spacing, which is what our motherboard actually is, and we'll get better contact with our CPU cooler using it in this setting. So you're going to want these all pulled to the outer setting where they're going to go through the outer holes. And if you're going with another manufacturer's board, ASUS, as far as I'm aware, is the only one that does this, you're only going to have the LGA 1700 holes, so it won't be quite as confusing as to which you use. And then we're going to have one of these spacers to go over each corner. Before we get our motherboard into the case, there's a little bit of preparation that we're going to need to do. So we're going to need to get the panels off. If there's any panels we're going to need to remove to get access to change fans or install radiators or any dust filters that we're going to need to remove, it's a good time to do it now. I've already done a full step-by-step build guide in this case where I cover all the case features in real detail. So if you are wanting to do a build in this particular case, it's probably worth checking that out to look at the different options that are available. Today I'm going to keep things more general, so if you were using a different case, you'll be able to follow along to this build guide, and I'm going to just focus on the main features you need to do this particular build. So our tempered glass side panel has a little thumb screw here, which we need to loosen, and then with that loosened, we can tilt the panel out from the top and then lift it away. Our other side panel, we can simply just pull it out from the top and lift away. Because we're going to be installing our radiator at the top, we're going to need to remove the case's top panel. So we've got two captive thumb screws at the back which need to be loosened. Once they're loosened, the panel just needs to be slid backwards to free it up, and then it can be lifted away. So this isn't a feature that you'll find in every case, but this particular case you can actually remove the top. And this is quite useful if you're going to install a radiator, because what you can do is remove the top, install it onto your AIO, and then set the AIO in the top of the case back in, which makes the installation much easier, but as well, removing the top gives you better access during the build. So the top of our case is held on with two screws at the front, so we'll go ahead and get it removed. With the two screws removed, all we need to do is lift the top of the case up and slide it forward and lift away. So taking a look at the front of the case, you'll notice we've got two 160mm RGB fans pre-installed. So there's no reason for us to remove the front panel for this particular build. If you do want to change the fans at the front or install your radiator at the front, you will need to remove the front panel at this stage. And in most cases, it's just a matter of pulling it off from the bottom to give you access to the screws for the fans. In this particular case, we've got these thumb screws which hold the front bracket in place, to which our fans are pre-installed. At the rear of the case, we've got a 140mm fan, which doesn't have any RGB on it pre-installed, which is great because we don't actually need to add any extra fans to this build. With the two at the front and the one at the rear and our radiator at the top, we're going to have plenty. There is an option to install two fans at the bottom in this case, although I'm not going to do it for this particular build. So we're now ready to get our motherboard installed in the case, but there's a few things I want to check before I do. And the first thing is that all the standoffs are installed in the correct position. So for an ATX and also an eATX motherboard, what you're generally going to do is have 9 standoffs in 3 rows of 3. And if you go along the vertical axis, the standoffs should line up with each other. In a lot of motherboards, you'll have a little diagram at the back, which tells you for ATX, micro ATX and ITX, where the standoff should be, and beside each hole there's a little corresponding letter to tell you which one you need to install where. If your standoffs aren't in the right place, in the case accessory box you get this standoff insertion and removal tool. All you need to do is pop it onto the end of your screwdriver, put it over the standoff, and that then allows you to turn to unscrew the standoff, and then if it's not in the right position you can move it to where you want to put it into and then screw again to tighten it up. So for our particular motherboard, the standoffs are in the right position for an ATX motherboard, and this case is a little bit unique in the fact that you have 2 different positions you can install an ATX motherboard in. And if you look at the back of the case, there's a down arrow and an up arrow. In the down arrow position, your motherboard is centered down towards the bottom of the case to make space for radiator and fans at the top if you want to go with an AIO. If you want to go with an air cooling, in general you want to move the standoffs up into the upper position in each of the 3 rows, and then your motherboard's going to be higher up in the case where you're just going to have fans at the top of the case. So this case is already set up for water cooling just the way we want it. The other thing to check is that this side bracket is in the right place. So we've got an ATX motherboard, so it is in the current position. If you've got an eATX motherboard, as I've already shown you, it's going to extend further over this way, and it would actually block these cutouts to the back of the case. So what we would need to do is remove these 3 screws, rotate the bracket round, so these cutouts would now be here, and then screw it back in again, and that would make space for the extra eATX motherboard. But as I mentioned, we've got an ATX motherboard, so this is right for us. Final thing to mention, our motherboard has an integrated I/O shield, which means that the I/O shield is already attached to the motherboard, so we don't need to worry about this next step. If you go with a lower spec motherboard, quite often the I/O shield isn't already attached and it comes separately, and it will line up with the back like this. So what you would need to do is install this in the case first of all. So to install it, all you would need to do is line it up with the cutout at the back of the case, and once you're happy everything's lined up, apply a little bit of pressure to it, and it's then going to clip into place. And it is very important, the back of this is metal and it can cut you, so take care not to cut yourself while you're pushing it into place, and you can hear that's just clipped into place. So that's all our checks done. We're about to put the motherboard in, but the last thing I want to point out is the middle standoff. It is different to all the other standoffs. It protrudes a little bit out, and the idea of it is once you get your motherboard in and the holes line up, this will go through the hole in the middle of the motherboard and help hold your motherboard in place. And this design varies from case to case. Some cases don't have it, others have it like this, and others have it where it protrudes a little bit, but the middle standoff is actually solid and you don't put a screw into it. This one protrudes, but it has a hole in it, so you're going to put your motherboard in and get a screw in the middle standoff. The last thing to mention is I'm going to show you installing the motherboard with the case upright, but you're much better putting your case down on its back and then setting the motherboard in, because you're not going to have to hold the weight of the motherboard to get it lined up. The only reason I do it this way is to give you guys a better view of things. Okay, so we can set our motherboard into the case, line it up with the cutout at the back, and then we'll try and get that middle standoff into place. And you can hear it's just clipped there, so the middle standoff is currently holding it. So I'm then just going to pass our middle screw through and tighten it up. Okay, so that should hold our motherboard in place. It's just a matter of getting another 8 screws into it. And in terms of the screws you use, there's a nice diagram in the case manual which tells you which screw to use. So the one we're going to use is the one with a little lip around the outside. The next thing I like to do in any build is get all our case cables plugged in, and the reason I do it at this stage is we've got loads of access to all around the motherboard at the moment. Once we start adding more stuff into the case, the access to all the ports is going to become more and more limited, so it's a good idea to do this now. So what do I mean by our case cables? Well, our case obviously has front I/O ports, and at the moment, because they're obviously not connected up to the motherboard, they're going to do absolutely nothing. So we need to make the connection to make these ports work. So we've got a power button and a reset button. We've got a combined audio jack for a headphone and microphone. We've got 2 USB Type A ports and a single Type C port. So running from our front I/O module, we've got these cables. So first of all, we've got our HD audio cable, which lets our headphone and microphone jack on the front of the case work. We've got our front panel connectors, and very nicely, Leigh and Leah have combined this into one cable for us. Sometimes you get these in a combination of 1 or 2 pin cables, which you need to plug into individual pins on your front panel header on your motherboard. So this is definitely much easier the way we have it here. We've got our USB 3.0 cable, which lets the 2 Type A ports in the front of the case work. And then we've got our USB-C cable, which lets the single Type C cable work. So the HD audio cable normally goes into the header in the bottom left-hand side of the motherboard. If you're using another motherboard, just check your motherboard manual, but this is normally where you're going to find it. And if we look at the header itself, you'll notice there's a pin missing on the top row. And if we look at our cable, you'll notice the cable has a hole missing on it. So it's only going to go in one way. And for this particular case, we're going to need to install it with the audio text facing up the way. So it's just a matter of lining it up with the header. And once we've got it lined up, a little bit of pressure to it, and it will simply slot into place. And then we don't want any excess cable at the bottom on display, so it's just a matter of pulling it gently through to the back. So next we've got our front panel connectors to plug into, and at the bottom right hand side of the motherboard is normally where you'll find this header. It looks like one big long header here, but it's actually only the pins over to the left hand side that we're going to use. So what we need to do is bring the cable through. And as I've mentioned, Leigh and Leigh have been really kind and combined them all into one easy cable to plug in. So we're just going to need to plug it in with the front panel text facing up the way, push into place, and then pull the excess cable through to the back. Now, as I've mentioned, in other cases you will get all these coming as separate cables. Some of them have 1 hole in them, some of them will have 2, and you have to plug them into individual pins on the headers. So if you do have this, what you're going to need to do is get your motherboard manual out and look and see what each of the individual pins does. And then you're going to have to line them up with the individual cables. So what I'll do is I'll put a little bit of footage up of me plugging this style of cable in on another build. So generally in the top row into pins 1 and 2 working from left to right are for power LED positive and power LED negative. So it's really important that you plug those into the right one. Next to that, you're going to have your power switch, and it doesn't matter which way up this goes, it can go in either way. Then moving back down to the bottom row, and again working from left to right, you've got hard drive LED positive and hard drive LED negative, so you're going to have to plug that cable in only one way round, making sure the positive and negative contacts are round the right way. And then next to that, into pins 3 and 4, you've got your reset switch, and like the power switch, it doesn't matter which way it goes, you can plug it in any way. Our USB 3.0 cable is going to go into this header here. Now what you'll notice is there's a little notch over the right hand side of this header, and if we bring the cable through, you'll notice that there's a little notch on one side of the cable, so it has to be lined up the right way round, so this clip is going to go over to the right hand side. Now these pins are really easy to damage, so what you're going to want to do is be really careful plugging this cable in. So we're going to bring it through, making sure this little raised area is facing to the right hand side. Line it up with the header, and we're going to take our time here. And it's only once we're happy everything is lined up that we're going to put some pressure on it. And you're going to get a nice satisfying click as it goes into place. Okay, so just above it, we've got our Type-C cable. So again, we're going to bring it through the cutout. We'll line it up with the header and push into place. So our case has a built-in fan and ARGB hub, so we're going to have a few extra cables to plug in because of it, but also because our fans are already plugged into it, a few less cables to plug in to the motherboard. So our front fans have 2 cables coming from each of them, and they're already pre-installed into the headers on the fan hub. So the first, if we unplug it, is this 4-pin PWM connector, which is going to power our fan and allow us to control the speed of the fan. So we've got one for each of the 2 cases front fans plugged into here and here. And the other cable is a 3-pin 5-volt ARGB connector. What Lee and Lee have done is daisy-chained the 2 of them together. So that's the 2 fans daisy-chained in together, which gives us just one header to plug into the controller. And that's then going to let us control the lighting on the fans. So I'm just going to put that back into place. And then we've got our rear fan. It doesn't have any RGB on it, so we've just got the 4-pin PWM connector plugged in. And then we've got some spare 4-pin PWM connectors if you wanted to add more fans in. And behind these protective covers here, we've got more 3-pin 5-volt ARGB headers if you wanted to add any other devices which have ARGB effects on them. So if this doesn't make a lot of sense to you now, the different connectors I've talked about and the ARGB headers, I'm going to cover all this when we come on to the CPU killer, so you will understand it at this stage. But really all you need to know is the case's fans are already installed into the fan hub, but we're going to have to connect the fan hub up to our motherboard to allow it to work. So coming from our fan hub, we've got 3 cables. The first is a 4-pin PWM connector, which we need to plug into one of the system fan headers in our motherboard, and that's then going to allow our motherboard to control the speed of any fans that we plug in to this controller. The second is another 3-pin 5-volt ARGB cable, and if we plug this into one of the ARGB headers in our motherboard, it's going to allow our motherboard to control the lighting effects of anything that we plug in to here. The third cable is a SATA power connector, and for this hub to work, it's going to need power. So we're going to need to plug this into our power supply to power it to allow it to work. And again, this is another common mistake a lot of people will make. They don't plug this into the power supply and then they wonder why their lighting and their fans aren't working. This will be the reason. If you don't provide this with power, it's obviously not going to work. So taking a look down at the bottom of the motherboard, we've got a system fan header. So I'm just going to bring the 4-pin PWM connector through. I'm going to line it up with the motherboard and push into place, and then pull the excess cable through to the back. Next to that, we've got 2 ARGB headers, and you'll identify an ARGB header from the diagram in the motherboard manual, but it generally has 2 pins, a gap, and 1 pin, and it is a 5-volt header for addressable ARGB. The other type of RGB header you will get is a 4-pin 12-volt header, and we have one of these up at the top of the motherboard. Now what's really important is you can't mix and match what you plug into where. You can actually damage your hardware if you plug them into the wrong place. So we've got a 3-pin 5-volt connector, so it needs to go into a 3-pin 5-volt header. So we'll bring it through the cutout. And you can see we've got 2 pins, a gap and 1 pin, and also in our cable, 2 pins, a gap and then 1 pin. So it's really important we line it up the right way with the header. And again, it's really easy to damage these pins, so you don't want to put a lot of pressure on it. You want to take your time, line it up, and only push it in when you're happy things are lined up. So we'll bring the cable through, line it up with the motherboard, and then once we're happy everything's lined up, we can just push it into place. And then again, we'll pull the excess cable through to the back, taking care not to put excess pressure on the cable where we can bend the pins. So if your case doesn't come with a built-in fan or RGB hub, all you would need to do is plug the individual cables that we have plugged into the fan and RGB hub directly into the motherboard. So the 4-pin or 3-pin fan connectors into a system fan header, and the 3-pin 5-volt RGB connectors, if you've got RGB fans, into an RGB header on your motherboard. The big advantage of this is cable management is going to be much easier because you're just bringing the cables through to the back, and if your motherboard doesn't have enough fan headers or RGB headers, this solves the problem for you. Again, what you could do is get an aftermarket fan and RGB hub if your motherboard doesn't have enough headers, or you just want to make it that little bit easier for yourself. So the only other cable that we have to plug in is this SATA power cable, which we'll do once we get our power supply installed, which we'll take a look at next. So the next thing to talk about is our power supply, and although it doesn't sound the most interesting component in the system, everything in the system needs stable, reliable power to function at its best. So it is actually quite an important component, and one that I wouldn't skimp out on. So the first thing to mention is size. This is an ATX power supply. This is an SFX or small form factor power supply. And for our mid-tower case, this is what we're going to want. If you're doing a mini ITX build, a lot of them you won't be able to fit this into it. And with your mini ITX motherboard, everything being smaller, you're going to need a smaller power supply. And you can also get an SFXL one, which is the same footprint here, but slightly longer this way. Downside of these is you've less to choose from. They don't tend to go up as high in terms of the wattage, and they're much more expensive for the equivalent ATX power supply. So assuming you're going with an ATX power supply, they do vary a little bit in their length. So it's important if your case is one of those more compact ATX cases, or you're wanting to install hard drives at the bottom, for example, the length is quite important. So check that your case's manual to check the power supply you're going with is going to be compatible. So that's the first thing. These come in a range of different types. You can see the type I've got here is what we call a fully modular power supply. None of the cables come plugged in. Big advantage of this is you only need to plug in the cables that you're going to use. And the advantage of that is that you're going to save space at the bottom of your case. You're not going to have a whole load of cables that you're not planning on using, but have to be in your build. You can leave them in the power supply box. You get what's called a semi-modular power supply. I don't have any of these to show you. Actually, all the power supplies I have on hand at the moment are fully modular, which tells you what my preference is. The semi-modular ones have your important cables plugged in, for example, your 24-pin cable, and also your EPS cable to supply additional power to your CPU. Now, they're essential cables you're going to have to plug in anyway, and you've got spaces to plug the other ones in. The non-modular power supplies come with all the cables plugged in, so regardless of whether you're going to use them, they're going to be in your build, and price tends to go down from that fully modular to the non-modular. Also, a lot of the cheaper non-modular ones, the cables won't look quite as nice as what you're going to get as you work your way up the power supplies. I would recommend spending money on a power supply and not going from one from an unrecognized name, because if something's going to set your PC on fire, it's going to be your power supply, so I would go for a good one. And in terms of the ratings, they range from bronze, gold to platinum. And again, I would probably try and get a gold power supply at the minimum. If you really are trying to save money, you can go with a lower efficiency power supply. But again, this is something that should last you from build to build. You can get maybe 10 years out of a power supply without having to change it. So it is worth investing in. A lot of your other parts are not going to last as long as this. So the next thing we need to consider is the wattage of the power supply that we're actually going to need. So it's hard to determine this without using an online calculator. So what I would recommend doing is heading over to one of the manufacturer's websites and putting in the specs of the system you're planning to build, and it will give you some recommendations on your power supply. So I did this over on BQAT's website, and it was recommending that although we could get by with a 750 watt power supply, it would be using at potential at its max up to 92% of the power available, which is too high. So really the minimum that we're going to need for the system that we're going to be building is an 850 watt power supply. So again here, I don't recommend you just go just under what your power supply is going to need. That's not very efficient for your power supply. It's going to run hotter. The fan is then going to kick up to cool the power supply down, and that's going to bring noise into your system. So you generally want to leave a reasonable headroom so that your power supply is running below its maximum load, where it's going to be much more efficient and produce much less heat. The other thing is you want to future-proof things a little bit. As I've said, a power supply can last for years and years. And again, the systems, the power demands are going up and up from generation to generation. So the last thing you want to do is have to change out your very expensive power supply that you bought. And it is worth, I think, leaving yourself a little bit of headroom. Final thing to consider is we've now got a new standard of power supply, an ATX 3.0 power supply, which is what I've got here. This is a 1200 watt Titan Gold from Montech. So it brings certain power standards to cover for the power hungry graphics cards that we now have, but it also brings a special connector, which is this 12 volt high power connector. So you've got one cable that goes into your power supply, and it can supply up to 600 watts of power for your graphics card. There is other ways around this. If you don't want to go with an ATX 3.0 power supply, you can plug in a standard PCIe cable, and then with your new generation of graphics card, you should get one of these adapters. This is for a 4070 Ti, so it's going to have two 8-pin connectors to give me a 12 volt high power connector on the other end. Problem with this is this does not look quite as clean. And I think if you don't currently have a power supply and you're buying one, to me it makes sense to buy an ATX 3.0 power supply with a decent range of power that's going to cover you for the next number of years. It doesn't make sense to buy an old power supply and get an adapter for it. So if you don't have an ATX 3.0 power supply and you don't want to use the horrible adapter that comes with the graphics card, an alternative option is to get a new cable for your power supply. So I've got a lovely Dark Power Pro 12 from BQuad. It's a 1200 watt power supply. It's about £300 worth, and it'd be awful just to have to get rid of that because it doesn't have the right cable. So BQuad produced this aftermarket cable for it. These two ends plug directly into your power supply, and then it gives you a 600 watt 12 volt high power cable to go into your new graphics card. So again, I'm focusing today mostly on building a cutting edge system with new components. I've done previous builds looking at the older components. The point of today is to get you ready for a system going forward, starting off in 2023. So for me, buy an ATX 3.0 power supply if you can, and it's just going to future-proof your system. The next thing for us to do is get our cables plugged into our power supply. So the power supply is normally labelled telling you what goes where. So our motherboard cable, our 24-pin cable, is going to go into these two headers here. So it's just a matter of lining the cable up, pushing, and you hear a nice click as it goes into place. And this is, and again, another step that a lot of builders who are new to building will get wrong. They'll build their PC and it doesn't work and they'll wonder why, and that's because they just haven't secured one of the connectors correctly. So take your time and make sure that everything goes in fully and it clicks nicely into place. So there we go, that's the 24-pin cable plugged in. Next we've got our EPS cables, and you'll see one side of the cable is labelled CPU and the other side is blank. So it's the blank side that's going to need to go in. So it's just a matter of lining it up and pushing into place. So this cable provides additional power to your CPU, and in general the motherboard varies depending on the number of these cables that you're going to need. Our motherboard actually has two 8-pin connectors. Some motherboards have an 8-pin, some have an 8+4, but ours has two 8-pin connectors, which means we can get away with just plugging one of these cables in, but because we've got quite a power-hungry CPU, and if you're wanting to overclock it, to get the most out of it, you're probably best plugging both cables in. But if for some reason you just had a power supply that had one 8-pin EPS cable, yes, plugging one of them will work, even if your motherboard has two 8-pin connectors. So we'll go ahead and plug in our second cable. And if we take a look at the second cable, what you'll notice is you can actually split it. So it's just a matter of pulling it apart. So you've got two 4-pin connectors. So for example, if your motherboard had an 8-pin plus a 4-pin, you can plug it in this way and just not plug the other one in. You would tuck it round out the back, out of the way. Our next cable is labeled PCIe 5.0. This is for our 16-pin 12-volt high power connector for our graphics card. So it's great that we only need one cable for our graphics card. So just a matter of lining things up and then pushing into place. So we've also got a SATA cable to plug in. It's going to go into these ones labeled Molex SATA over to the right hand side, the 6-pin connectors. So just a matter of lining things up and pushing into place. And you can see this one cable has actually 4 SATA connectors, so it'll be enough to power 4 drives, or we can plug in our RGB hub into here, and we've still got space for 3 drives. So that's our power supply ready to go, but what I want to do is show you how you would set it up if you were going to use the adapter that came with the graphics card. So what we need to do is plug in a PCIe cable to here. And looking at the adapter that we have, it's got 2 8-pin connectors. So looking at the cable we've got, it has a 6+2 pin and a 6+2 pin. So you would think actually I can just plug these into the adapter. But what you're generally going to want to do, because so much power can come through this cable, I would actually use 2 separate ports on the power supply. And in fact, if I had one that needed 3 ports, I would be using 3 separate ports on the power supply. So we'll plug in another PCIe cable, and then all we would need to do is line this up with our adapter, push into place, and then we'll take one of the connectors on the other cable, line it up with the adapter, and push into place. So you can see why this one cable is a really useful thing to have. We've got this one cable to provide this power, which is going to look nice and clean, versus having this adapter on display with all these other cables to manage. So I know which solutions I would prefer. So I'm going to remove the adapter. So just a couple more things to say about our power supply. This is our power supply's fan, and this is its intake. So in general, you're going to want to install the power supply facing towards the bottom of the case. There's normally a cutout at the bottom for fresh air to get in, and the power supply is then going to take air in through this fan here, and then exhaust it out the back, which is normally out the back of the case. And then the last thing I want to point out about this power supply, it has a smart zero fan mode. So when the power supply is under low load, the fan will stop spinning. So that switch is currently turned to on. If we turn it off, the fan will run all the time and the power supply will be louder. So I'm going to leave that turned to on, which means when our power supply is under low load, the fan won't spin and our PC will be quieter. Some power supplies have this switch, others don't, but the more high-end power supplies will at least offer this as a standard feature where you don't have to press a switch or give you the option. The cheaper power supplies, quite often what you'll find is the fan will spin all the time. And again, if you're running your power supply, you've only just met your system's requirements, your fan will spin much more because your power supply will be less efficient, it'll be making more heat, running hotter and noisier. The final thing I want to mention is cable extensions, and I do use these in a lot of my builds. So all they really do is provide an extension from your power supply cable, which looks slightly better. They come in a variety of different colors. So these are purely for aesthetics. So all you would do, for example, this is an EPS cable extension. They quite often come in a pack. All you would do is simply slot it into place like this. And this bit is on display in the front of the case. It's a slightly nicer looking cable. They come in a whole variety of different colors, and it's going to improve the look of your build, but offer no functional benefit. The downside is you've increased the amount of cable that you have to manage at the back of the case. These cables aren't quite as nice to manage as well. They tend to be stiffer and thicker, particularly when you come onto the 24-pin cable compared to this. So you're going to make cable management a little bit more difficult. For the purposes of today, I'm just going to keep this build simple without any cable extensions. But if you wanted to add them in, it would be quite a simple step to do so. So just before we install our power supply, it is worth pointing out that a lot of cases will have a removable power supply bracket at the back. This case doesn't. It's normally held on with a couple of thumb screws which you remove. You're then able to fix the bracket to the back of your power supply, and then the advantage is you can slide your power supply directly in from the back, which is a little bit easier. If your case doesn't, it's no big problem. You put your power supply in from the side and fix it directly to the back. The other thing to point out, we've got a vented panel at the bottom and actually got a dust filter here. So our power supply is going to get cool air from under the case. So when we install it, it's important we install it with the fan facing down the way. Okay, so we can slide our power supply into the back of the case. Just a matter of lifting the other cables out of the way and then we can slide the power supply in. And direct it all the way towards the back of the case. And then we can secure the power supply into place with 4 of the larger screws from the case accessory box. Our 8-pin EPS cables are going to go into these 2 headers at the top left of the motherboard. So we can bring them through the cutout at the top, line them up with the header and push into place. And then we'll bring the second one through as well. Again, line up with the header and push into place. And then we'll just pull the excess cable through to the back. So our 24-pin cable is going to go into this header here, and you'll notice we have a little notch over to the right hand side. So the clip on the cable is going to have to go on this end. So we can bring the cable through the cutout. We'll go ahead, twist it round and line it up with the header again, making sure the clip is over to the right hand side. And once we're happy everything's lined up, it's just going to be some firm pressure to the cable and making sure it clips into place. And then again, we'll just pull the excess cable through to the back. And then we just need to plug the SATA cable coming from our fan stroke RGB hub into the SATA cable coming from our power supply. The next thing for us to chat about is cooling, and for most people building a PC, you're choosing between air cooling and an AIO. In general, if you're building your first or second PC, you're not going down the custom loop route, and either of these two would be perfectly fine options. Which you go with really depends on the type of CPU that you're trying to cool and how easy or difficult it is to cool, but there's probably options in both for either an easy to cool CPU or a difficult to cool CPU. So some of the differences, some people really just don't want any water at all in their system where there's any risk of leak at all, although it's fairly low with a lot of the AIOs including anti-leak technology. There still is a risk to having water in your system, and some people aren't prepared to take that and are happy with an air cooler. Downsides of an air cooler, particularly if you're going with a big beefy air cooler to cool a hot CPU like we have, you tend to need to use a premium cooler, which comes at a cost in terms of price, but also in terms of the size it's going to take up in your case. And it is actually going to block quite a bit of your build. So for our R7900X, either the Dark Rock Pro 4 or Noctu's NHD15 would do a good job of cooling it, but this smaller with a single fan cooler would really struggle to cool that CPU. But for something like a 7600, this would be a perfect CPU cooler. So you have to match your cooler to your CPU. How do you do that? Well, you look at the power requirements of your CPU, match that up with the manufacturer's website for the cooler, and they'll give you a recommendation if the cooler is suitable for that power of the CPU that you're going for. So there's a TDP rating, and you need to match it up to see, is the cooler going to be suitable for the CPU that you're going to be using, and whether you're going to be overclocking that CPU or not. So while I've said both of these will probably do an okay job for our 7900X, depending on where we install the IO, if we install it in the right place and set it up correctly, we should get lower temperatures with a 360mm IO than one of these premium air coolers. I also think it's going to look slightly better. But again, that's very subjective. In general, installing an AIO is more difficult than installing an air cooler. In my last full step-by-step build guide for beginners, I did an air cooler. So what I'm going to do today is show you how to install this AIO. I've got lots of separate guides to install an air cooler. If you want to go down the air cooled route, really easy. Just swap this step out for one of my standalone guides to install an air cooler, and you'll be good to go. And as I've mentioned, if I'm doing an air cooler, I would put it in at the stage of working on the motherboard on the table, and then just put the motherboard and cooler directly into the case, and you're ready to go. The IO is just the bracket I put on at the start, and then we'll install the rest of it later on. So before we come on to talk about the orientation and sizing of AIOs, I think it's important to talk about airflow through a case in general. And there is normally a couple of rules in terms of airflow. In general, the front of the case you're going to want to have set to intake. The top of the case and the rear of the case you're going to want to have set to exhaust. And if you have any fans at the bottom of the case, generally they're set to intake. So the reasons for this is your graphics card is going to be sitting here. You don't want to be exhausting air or taking it away from the graphics card, so bringing fresh air up to the graphics card would be a good idea from the bottom. Again, the front of the case is your major source of intake for most cases. Some cases will have an intake on the side, but again, it doesn't make sense to be exhausting out the front because you're sitting at the front and the last thing you want is lots of hot air coming up and hitting you in the face. So in general, that's why the top of the case and the rear of the case are set to exhaust. And if you look at the way Lian Li have installed the fans in this case, they're making it very clear for you, this is how you should generally operate in the case. The first thing to do is talk a little bit about fan orientation. So we take a look at the fan. This is the front of the fan. The fan blades are unobstructed. If we turn it round, the rear of the fan, you generally have a sticker on it and you have these little bits of plastic blocking the fan blades, indicating that it is the rear of the fan. So when the fan spins, air is going to be coming in from the front and out the back. And on some fans, you'll have a little arrow telling you the direction of airflow if you're not sure. But majority of fans, this is the front, this is the back, air comes in the front and out the back. And you can see the way Lian Li have set this up. This is the front, so it's going to be bringing air in from the front. Again, this is the front of the fan, so that air is coming out the back. So if we go back to our case, up at the top we've got space for a 360mm AIO, which is going to give us lots of cooling potential. The larger your AIO, the better the cooling potential. So you do get AIOs in 120, and in general it won't compete with a good air cooler. A 240mm AIO set up the right way will maybe just about compete with a premium air cooler, whereas a 360 will generally outperform a good premium air cooler. So we're going to set our AIO at the top, sticking with these general rules and having it set to exhaust, which means we're going to have the front of the fans facing into the case, where it's going to be taking air from in the case, exhausting it through the radiator and out the top. So this is our AIO, and it's probably worth just giving you a brief talk through how it works. So taking a look at, first of all, this is our pump, and we've got a cold plate, and the cold plate goes on top of the CPU. We've got some tubes and a radiator. So the pump drives water over the cold plate, through the tubes to the radiator. The cold plate heats the water up, so hot water goes out to the radiator. We're going to have fans on the radiator blowing cool air through the radiator, which is going to cool the water down, and the cool water comes back to the CPU and helps cool it. So there's a circular motion of water round the radiator and back to the cold plate, helping keep it cool. Now there's a few things we can do to cool the water better. So it depends how we set this radiator up in the case. If we have it set up to intake, for example, the radiator is taking cool air from outside the case and blowing it through the radiator. For example, if we had this up at the front of the case set like this, cool air would be coming in from outside the case, going through the radiator, and would give you better cooling potential than if we did what I was talking about in this particular build, having it set to an exhaust at the top of the case, whereas slightly hot air from inside the case will be going through the radiator, where it's going to have less cooling potential than that cool air from outside the case. So that's the first thing. If you have your AIO set to an intake, for the same size of AIO, you're going to get better cooling than having that AIO set to exhaust. And it can be up to about 8 degrees is from what I've found in most of my testing between an intake and an exhaust. So you might ask me then, why am I installing my AIO as an exhaust in this particular case? And there is a good reason for it. While we would get better CPU temperatures if, for example, I turned the fans round, rather than having them this way round where they were exhausting at the top, they were set to intake. So they were drawing cooler in from the top of the case through the radiator. My CPU temperatures would be improved by doing it this way, but then I would be dumping lots of additional heat into the case. It's going to heat up all the other components in the case, it's going to heat up the graphics card, and it's going to interfere with that normal pattern of airflow through the case. So there is definitely certain circumstances I would do this, but as we've mentioned, stick to those general rules. Have the top of the case set to exhaust, the front of the case set to intake. So you might be asking, why don't we then put the AIO at the front of the case and have it set to intake? And the big reason for this particular build is we've got nice 160mm fans from Lian Li there that won't fit anywhere else in the case. So we have to leave those at the front. Now it is important to mention, this again is very topical. If you are going with a front mounted AIO, There's a recent trend for people to want to install it with the tubes in a downward position. So I've got tubes up here and the pump here. So in general, as long as your pump is not the highest point of the loop, any additional air that will develop in here will collect up at the top of the radiator here, and it won't collect in the pump. So for me, this is okay. It has become very trendy recently to install the radiator in a tubes down position. And in general, then any air that gets into the system is going to collect up the top of the radiator, where it's not going to be circling about around the tubes. The downside with doing this is that the tubes look horrible installed this way round. And quite often, if you're going to have a graphics card getting in here, the graphics card is going to be abutting the tubes. So in theory, this would work slightly better and you're going to have less noise potentially from the I/O. If you can imagine, if you have it installed around this way, and there is a little bit of air at the top, where these tubes are coming in, there may be a little bit of turbulence and you might hear some noise with it as fluid evaporates over time. But in general, I'm installing my I/O at the front with the tubes up most of the time and I don't get any issues with it. And final thing to mention about I/O is we've already mentioned the larger it is, the more fans and the bigger the radiator, obviously the better your cooling potential is. As they get bigger, they get more expensive. But the big advantage for me is I think you should fill the space that the case offers. So if you have space for a 360 at the top, it makes sense to put one there from an aesthetic point of view. If you're only occupying part of the top of the case and it's not symmetrical, it doesn't look good. So there's space at the top of the case for a 360. In my opinion, put a 360 there. The same at the front. If you were to put a 240 and leave a gap where a fan and radiator would have fitted, it's not going to look very good. So that would be, particularly for the CPU I'm going with, particularly having an exhaust where it's not going to cool as well as having it intake, I would recommend a 360mm I/O. But again, depending on the CPU you're going with, you might decide that actually an air cooler would be the best cooler for you, and that's completely fine. We're now ready to start working our I/O, and the first thing is to set the fans onto the radiator. So I've already lined it up in the case, and the tubes are going to be over to the front of the case, which means this is the back of the radiator. So I'm going to have the fan cables coming out towards the back. And as we mentioned, we want it to be exhausting out the top of the case, which means the front of the fans facing into the case and exhausting out the top. Then we're going to take the long radiator screws that come with the I/O and install them through the fans and into the radiator. So we're going to tighten them up, but just fairly gently to start with. So all I'm really doing is just getting these screws to catch, and once we've got them all in, then we'll tighten them up. Okay, so now that's all the screws in loosely, I'm just going to tighten them up slightly. Again, we don't want to over tighten. If you over tighten things, there's a risk of damaging things, and also the fans are bent out of shape, they're not going to spin easily, and you might get additional noise, so it's just very lightly tight. And I also think it's a good idea when you install fans just to give them a little spin, just to check they're able to spin freely and there's not any noise associated with it. So coming from each of our fans, we've got a standard 4-pin PWM fan connector. The problem is we've only got one CPU fan header. But what Deepcool do is they include this triple fan splitter cable. So all we need to do is plug one of the connectors from each fan into this cable. So it's just a matter of lining things up and pushing. There we go. And that now means all three of the fans just have one 4-pin PWM connector, which we can plug into our CPU fan header. And that's going to allow our motherboard then to control the speed of the fans and adjust the speed of them depending on what the CPU temperature is. So again, one of the nice things about our case is it comes with a removable top bracket, so we can set it into place. And then what we're going to do is use these shorter radiator screws to secure the top of the case to the radiator. So again, I'm just going to put the screws in loosely until I've got them all in place. So at the moment we have a little bit of movement in the bracket, so we can slide it to exactly where we want it and then just tighten up the screws. And again, take care not to over tighten things, because we bend the radiator out of shape, we can damage it. So the top of this case is a really nice way of being able to route the cables directly into the rear compartment rather than actually seeing them in the main body of the case. So to do that, we would need to route our fan cables through this cutout here. So the easiest way to do that, I think, is just to unplug them from the splitter cable. And then what we're going to do when we install it into the case, the cables are simply going to route down here and we're directly into the rear of the case. So now I want to take a look at the cables coming from our pump. We've got two cables. The first is a 3-pin fan connector. We're going to plug this into the pump header on our motherboard, and it's going to allow us to control the speed that the pump runs at, depending on the temperature of our CPU. Now is probably a good a point as any to discuss the differences between 3 and 4-pin connectors, and most of the time this is going to be relevant to the fans that you're using. So in general, I do prefer the 4-pin fan connectors because you're going to be able to run these in PWM mode. Anything with a 3-pin connector you can't run in PWM mode. PWM mode really is just a way of controlling the fans. The two most common ways that most motherboards will control your fans is either PWM or DC mode or voltage controlled. So with voltage controlled, and this is really the only option you have with a 3-pin connector, you adjust the voltage applied to the fan of the pump to control its speed. The slight issue with this is you can't reduce the voltage all the way down because the fans will stop spinning or the pump will stop working. With PWM, what you do is you apply the full voltage to the device at all times, and it has then an additional connector which controls the pulses. So it will have the device on for a certain period of time and off for a certain period of time, and that alternating on and off will adjust the speed of the device. And the big advantage of this is you're going to be able to run your devices at much lower speeds reliably than what you can with voltage control. And again, the big advantage of this is that you're going to have a quieter device because your fans will be able to run much lower when the PC is under low load, whereas with voltage control they're going to have to run much higher even though they don't need to be at that rate. It doesn't matter so much for a pump because the pump I generally run at full speed, but it does have some implications for how you set your devices up in the BIOS. Anything with a 3-pin or a 4-pin connector, as I've mentioned, you can run it in DC mode. You've got a choice, but I don't think it's a good choice with a 4-pin connector because PWM mode would be better. The one place you can get into issues is if you take a 3-pin connector and don't change the settings in the BIOS to from PWM to voltage controlled, the device will just run at 100% all of the time. So I'll be covering this when we get into the BIOS and setting up the devices depending on the connector in them. If you want to keep it simple, run your 3-pin devices in DC mode, run your 4-pin devices in PWM mode. And if you ever turn your PC on and your fans are just incredibly loud and they've got 3-pin connectors on it, the chances are your motherboard is currently running them in PWM mode. It doesn't have the additional pin that it needs to control the speed, so it'll just run at 100%. And you need to go into the BIOS and change it to DC mode. So hopefully that makes sense to you. The other cable coming from our pump is a 3-pin 5V ARGB cable. And this in general is to power the lighting on the pump and also to allow you to adjust the lighting on the pump. It doesn't serve any function, so if you didn't plug this in, your pump wouldn't light up, but it would work perfectly well because you plugged in the power connector here. ARGB headers on most motherboards are quite limited, so what Deepcool have done is got a little splitter cable here. So what you could do is plug this into your motherboard, and then the other end, you've got a spare header. You can plug another device into it. So with us, we've got an ARGB hub in our case, so we probably will just plug this into the hub rather than plugging it directly into the motherboard. If your case doesn't have one of these, just plug it into an ARGB header on the motherboard. So we do have a couple of additional steps to take with our pump before we're ready to install it. The first thing is this mirror is just really a cover which is magnetically attached, so it can simply be pulled off during the installation. And you can see here the ARGB device is just connected to it. It's just the lighting, whereas this is the bit that actually does the cooling. It is important to mention if you're getting the IO from new, the thermal paste will be pre-applied and there'll be a protective plastic covering over the cold plate. In general, you're not going to want to remove that until you're ready to install it, but you don't want to damage the thermal paste. I've used this AIO before, which is why there's no thermal paste on it. We now need to put the brackets on, and there's different brackets depending on whether you're installing it on an Intel or AMD motherboard. So I'll show you it for the AMD motherboard. So I'm doing this on the table at this stage because there's not any thermal paste on it. If you were installing it with the thermal paste pre-applied, I would install the AIO in the case and then install the bracket separately, because if you take the cover off and put the bracket on, you're not going to be able to put the protective cover back on again. So all we need to do is set the bracket up into place. We can take one of the screws that comes with the AIO and set it in. And the nice thing about this AIO is it's actually magnetized, so it's going to hold the screw into place, which really makes a difference. And then it's just a matter of screwing it into place. And like with most things in PC building, I'm just putting this in very loosely to start with till I get the other one in. And then once we've got the other one in, we'll tighten both up. And then same again on the other side. We're now ready to set our AIO into place at the top of the case, and just as I do, I'm going to pass the cables through this cutout at the top. And then we can slide things down and into place. Next thing to do is get the end of the triple splitter cable with the fans and the radiator plugged into the CPU fan header. We've got 3 fan headers at the top. The CPU fan header is the one furthest to the left. So I'm going to bring the cable back in through the top cutout, tilt our AIO up at the top, and that's going to give us better access to the headers. So I can simply line up with the header here and push into place, and then tuck the excess cable through to the back and lower things down again. So we're now ready to install the pump on the motherboard, and same as actually installing the motherboard into the case, you'll find this easier with the case down its back. I just won't get a good angle for you if I do it this way, so that's the only reason I'm installing it with things facing up. Again, you should have some pre-applied thermal paste on your AIO if you're getting it from new. I don't, so I'm going to add some to the center of the CPU. So the AIO that I'm applying here actually comes with thermal paste pre-applied, and you've got this hard plastic cover that comes over the top, so you're not going to forget to take that plastic cover off. Some of the AIOs will come with thermal paste in the box, so you're going to have to add your own like I did in the video, but quite often they do have a plastic wrapper over the cold plate that you're going to have to remove before you use the AIO. It is important you remove the plastic from the cold plate, because if you don't, it's not going to actually cool your CPU very well, and you'll be wondering why your CPU temperatures are high. Also, what I'm going to do is just help organize this cable by tucking it round the cold plate here, which is just going to mean I'm going to be able to control it up towards the top of the case. And then we can line the bracket up with the standoffs we put on earlier on, and if we apply a little bit of pressure to it, that's just going to keep it held in place. And then we've got one of these thumb screws to go onto each corner. And then what we can do is just tighten things up with a screwdriver. In general, you want to go from one corner to the other, tightening up a little bit at a time. Okay, so that's our pump secured. You can see how having the cable routed slightly around the bracket is going to help organize it. We want to get it up to our pump header, which out of these 3 headers is the one furthest to the right hand side at the top. And again, it's just going to help to lift up the radiator at the top. Now, because we've got a 3-pin cable and a 4-pin header, it will only fit onto the 3 pins over to the right hand side. You'll notice at the top of the header there's a little bit of plastic which is going to limit where you can plug it in. So don't worry about plugging it into the right 3 pins, it'll only go into the right 3 ones. And then we'll bring the excess cable up at the top. And we can lower that back down again. So you can see there the cable actually looks nice and tidy, and you can barely see any of it. So at this stage we can return the mirrored cover to the pump. It's just a matter of lining it up and then it will magnetically attach. And then we've just got the cable to route up towards the top of the motherboard. And we'll just bring the cable out the back. And then at this stage we can then secure the top of the case into place. So up at the top of the case, all we need to do is plug the RGB cable coming from the pump into one of the RGB headers on our hub. So just a matter of pull the protective covering off, So we're going to want to make sure we lined up the right way. We've got 2 pins, a gap and 1 pin, so that's the right way round. And then it's just a matter of getting things lined up. Once we're happy everything's lined up, we can just push things down into place. So as we mentioned, if you don't have a case with an RGB hub, we're just going to plug this directly into our motherboard. But it does make sense because we're just going to need one RGB header on our motherboard and all the RGB is going to sync up. So another mistake that a lot of people make when building a PC is they set all their fans up to run off the CPU temperature. And this is something that can drive you absolutely mad. Because when you're working in normal tasks on your PC, your CPU temperature will have little spikes in it, where maybe it goes from 30 to 55 degrees. And what happens if you've got all your fans set up to react to the CPU temperature, all your fans in your system will suddenly ramp up at that increase in temperature. It lasts for a short while and then it goes down again, and then it happens again. So you'll be sitting beside your PC and it will drive you absolutely mad that all your fans are suddenly cycling up and cycling down. So there is a way around that if that is driving you currently mad or something that you want to avoid. What you should generally have is your CPU fans should definitely be reacting to your CPU temperature, going up and down like that so they can keep your CPU cool. But you don't necessarily need all your case fans responding the same way. So for me, there's 3 different ways that you can set up your fans to avoid this. The first is you can just fix the speed of your system fans so that they don't react to the CPU temperature and they just provide a constant level of flow that the noise is acceptable to you. And then if it's only your CPU fans that are spinning up, they're going to be less noticeable. The other thing that you can do is you can, probably this is the quickest one, is just set up your fans to react to the system temperature rather than the CPU temperature. It's going to change very slightly as the CPU heats up, so it's pretty much going to do the same thing. Your speed of your system fans isn't really going to cycle up that much when your CPU goes up. As the system heats up gradually, definitely they will go up a little bit. The third thing that you can do, it's a little bit more complex than the other 2, but it is set up a custom fan curve. And in general, what you want to do where the CPU is cycling up and annoying you during those low intensity tasks, it's not really hitting that high a temperature, you want to flatten the fan curve slightly so it's not as obvious a ramp up in the fans. In general, it's that steep curve that the fans are going from quite low to quite high when the CPU is under quite a low load and the temperature is not going up that much that is probably driving you mad. Whenever your CPU is under a high load and a high intensity task at a high temperature, you want that nice steep fan curve so that it actually does a good job of keeping your CPU cool. So another important topic to mention here is the type of pressure you have in your case. So it can either be positive pressure, negative pressure, or neutral pressure. So with positive pressure, for example, if you had 3 fans at the front and 1 at the rear, you would have more fans bringing air into the case than exhausting them. So that's positive pressure. If you had it the opposite way round, you only had 1 fan bringing air in, but 3 exhausting it, that's the situation where you have negative pressure. That single intake fan, providing the fans are of the same speed and the same type, is not going to be providing enough air for those 3 exhaust fans. So in that situation, you're going to bring more air into the case through the other cutouts. And that is why people worry about negative pressure, because rather than coming through the filtered intake at the front where you want to get air, it will draw it in from the PCIe slots and other gaps in the case. And the worry is that those slots aren't filtered, so there's risk of it bringing dust in. And then if you have neutral pressure where you have a balanced intake and output, that's the other situation that you can have. So in general, when building a PC, most people prefer to have either a balanced system or to have positive pressure to avoid that risk of dust being brought into the PC. So it's not just quite as simple as matching the number of fans up. The fans may be of different sizes and different locations. They may have different speeds that they run at. You may have set the fan curves up differently. If there's a dust filter in one place or not, that's going to provide more resistance. So the same fan running at the same speed will be shifting less air if it's passing through a dust filter where there's no dust filter on the other side. And the other thing, if you have the fans on a radiator, again, that's creating more resistance as well. So they will be shifting less air than a fan that's not on a radiator. So it's not quite as simple as just managing up those fans, but it is something to think about, particularly if you're adding extra fans into the system. Extra fans isn't always good. Sometimes it will affect the airflow in the case, and you might turn a case from positive pressure into negative pressure and bring more dust into it. The other thing it might do is alter the airflow in the case and actually make the thermals worse. So if you are planning on building in a case, it is worth checking out if anybody's done a best fan configuration for that case, because it will help you decide whether adding extra fans in or not is a good idea. But in general, it's worth just keeping those rules in mind that you would probably like to have your system either balanced or in positive pressure, and trying to avoid negative pressure if at all possible. So although I normally install SATA drives in the build, I did say I would show you how to install them for completeness. So probably the best place to install them is on these removable brackets at the back of the case. So we need to remove the thumb screws at the top, and then we can lift the bracket up, tilt it out. So all we're going to do is set our drive onto the back of this. These are the connections that we're going to need to connect up. And then we can turn things around. If we line the holes up, we're going to use exactly the same screws we used to secure the motherboard to secure the drive to the back of the bracket. It's probably easier for me to show you how to install the cables before we put the drive back onto the bracket. So we take a look, we've got two L-shaped connectors on the underside of the drive. The smaller one is for a SATA data cable, which is going to connect to our motherboard, and the larger one is for SATA power, which is going to power the drive. So in our motherboard box, we get a SATA data cable, which again has an L-shaped connector on it. So it's just a matter of lining things up the right way and then pushing it into place. And again, if we take a cable coming from our power supply and push it into place. So now that we've got the drive connected up, we can install it back on the bracket again. Just a matter of sliding it into place, sliding it down, and then we can re-secure it into place with the thumb screw. We can then pass the other end of the SATA data cable through to the main body of the case, and then we'll get it plugged into one of the SATA ports on the motherboard. This cable does have a little locking connector on it, so if you want to remove it, you have to push the silver connector in, and then that's going to free the cable up. In terms of installing a 3.5-inch hard drive, we've got a hard drive cage at the bottom which can accommodate two 3.5-inch drives. So we just need to remove a drive tray by pulling it out. Importantly, we're going to want to install the drive with the I/O facing the back of the case, and then it's just a matter of sliding the drive into place. There's little holes on the drive at the side, and we've got little notches on the drive tray, so it's just a matter of lining these up, and then it's simply just push the drive tray into place, and that's going to hold the 3.5-inch drive, and then we can simply slot it back into the drive tray. And then that's going to clip into place. And it's just exactly the same process for connecting up the 2.5-inch drive. We've got a SATA data cable here and a SATA power cable here. I'm not actually going to install this. As I've mentioned, I'm not a big fan of 3.5-inch drives in my build. They are quite noisy, so I'm not going to install it. So what I normally do in most of my builds is actually remove the hard drive cage if I'm not going to use it. If you need more space for 2.5-inch drives, you can also install 2.5-inch drives in these drive trays as well, but you are going to have to screw them in from underneath. So we'll remove the drive tray. And if you want to adjust the hard drive cage, you can either half it down by removing the top half. There's a lever here you pull up, and that removes the first half of the tray. And again, that's going to make you plenty of space. But I'm just going to go ahead and remove the whole thing. So there's a lever at the bottom we pull up, and then we can pull the drive tray towards us and lift it all the way out. And it's just going to mean we're going to have more space at the bottom for our power supply cables. Last thing to mention about drives before we move on is this is a 500 gigabyte SATA SSD, but the NVMe M.2 drive that I want to install Windows on, the Gen 4 drive, is also 500 gigabytes. So when I go to install Windows, it might be difficult to tell which drive is which. And obviously if I install Windows on here, it's not going to run anywhere near as fast as the Gen 4 NVMe drive. In general, what I have found is SATA drives tend to show up first in Windows, so it would generally be the second 500 gigabyte drive that I would want to install onto. But there is a more fail-proof way of getting into issues and installing Windows on the wrong drive and then having to repeat everything. And that is simply just to unplug one of the cables from here, so this drive doesn't show up at all as an option. Install Windows on the M.2 drive, and then plug this back in and then install it onto Windows, which is the option I'm going to go with. So we can pick one of these cables, either the power cable or the SATA cable. It won't show up with one of them's unplugged, so we'll just simply unplug the SATA data cable. So just a matter of pressing the little cable in and removing it. So when we're ready to install it, all we need to do is plug that cable in. Just before we get our graphics card in, the last thing I want to mention is the option of installing fans down at the bottom. So we do have these removable brackets at the bottom. You are able to mount SSDs on them. The other option is to put fans. To do fans, you need to remove the 2 screws at the front. And then the brackets you're simply able to tilt up and lift away. So if you were going to install fans, you would install them with the cables facing towards the back of the case, so they're going to be out of the way. And importantly, we've talked at the bottom of the case, any fans you install, you're going to want to have them as intake, so they're bringing cool air up to the graphics card. So normally when you're installing fans in, you use fan screws and screw them in from the back end. The problem is getting a screwdriver in here is going to be quite difficult. So Leon Lee have got custom holes here, and you're going to secure them the same way you would secure the fans to the radiator on the AIO. Leon Lee include these long radiator screws. You're simply going to pass them through the fans and then screw them in to the underside of the case. We would then simply pass the cables through to the back, and again we've got 2 familiar connectors on them. There's a 4-pin PWM cable and a 3-pin 5V RGB cable. Remember, if you don't plug the RGB cable in, the fan will work perfectly well with the 4-pin PWM cable plugged in, but it just won't light up. To get it to light up and control the effects, you're going to need to plug this in. For us, it would make sense to plug these into the controller that we have at the top of the case. If you're doing a different case and you don't have them, it would just be a simple matter of plugging these into your motherboard, into a fan header and an RGB header. And like most things, there's limited RGB headers, but you are able to daisy chain the fans together. Final thing to mention on fans before we get on to installing our graphics card is I have shown you how to install an AIO and case fan that run off the standard fan headers on the motherboard and standard RGB headers to control the lighting effects on them. It is important to mention that there is other options for controlling both the fan speeds, the pump speed, and also the RGB effect on the fans. And a lot of other manufacturers, compared to the ones that I've used here, will actually use a little hub to control those. And either your fans or your AIO plug into the hub plugs in with a USB 2.0 header to your motherboard, and you install some custom software from the manufacturer, and that will then let you control the devices plugged into that hub, be it fan speed or RGB effects, without using the standard headers on the motherboard. This is getting more common, and it varies widely between different manufacturers, so obviously I can't cover all the possible options here today. But if you have an AIO that has a USB 2.0 header, or you have a fan that requires a hub to work, it is going to be slightly different than the steps that I've shown you today. So if you do want to keep the build fairly simple, using fans that just have the standard fan connectors and RGB headers on them, and using an AIO that doesn't have a USB header, you should be able to follow this guide without any difficulty. So the next thing to talk about is graphics cards, and really which graphics card you go with is going to depend what you're planning on doing with your system. If you're building a gaming PC, the graphics card should be the most expensive part in your system. And which one you need and how much you're going to need to spend on it, the way to tell that is to go and look at the benchmarks. Look at the games you want to play in the resolution that you want to play them in, and see what the different graphics cards will give you in terms of frame rates. Remember to factor in how much your monitor will go up to, because there's no point getting a graphics card that will output 300 frames per second if you can't see that on your monitor. And is it really worth paying all that extra money for all those extra frames? So you're going to have to weigh all those things up. And in fact, when you're building your whole PC, this is what I would strongly encourage you to do. List all the components and write the different options that you have in terms of pricing beside each of them. And then you're going to go through and pick all the different options. In general, what I think you're trying to do with most of all your other components is, can I really sacrifice this component, for example, your power supply, can I bring it down to this? Can I drop the RAM down to this? Can I drop the cooler down to this to enable you to go up to the next level on your graphics card? Because this is where you're going to get the most bang for your buck in terms of spending your money, in terms of that raw gaming performance. If you're planning on building your PC mostly for content creation, whether you go for a good graphics card depends on what you're actually doing with it and what software package you're planning on using. I use DaVinci Resolve Studio, and a really good graphics card does make a good difference in most of the tasks you're doing in DaVinci Resolve Studio. If you get the free version of DaVinci Resolve, the graphics card definitely helps with some of the tasks, but a lot of the other tasks that will be used in the Studio version, it uses a CPU for. So it can't make full use of the graphics card in the free package. So it might not be as good an investment to buy a really good graphics card if that's not what you're doing. A lot of the other packages, they might not really use the graphics card at all, and they rely mostly on the CPU. So you really are going to have to check out the benchmarks for the package you're planning on using to see, does a good graphics card make a difference? And in some of them, you're actually better spending your money on the CPU rather than the graphics card. Well, in terms of looking for gaming benchmarks, they're really easy to find. Everybody loves benchmarking these things. You go onto YouTube and you'll find really good data if you're building a gaming PC. For video editing and content creation, there's less out there, but a really good source is Puget Systems. That's where I go to when I'm thinking of making upgrades to my video editing PC. They've got really good information, and I'll put a link to them in the description. So go onto there, look at the package you're planning on using, and see what difference the graphics card makes and decide, is it worth spending how much of your money on that card. The other thing to look at is if you're building your PC for browsing the web, using PowerPoint and Word occasionally, and simple tasks like that, you might not actually need a graphics card in the system. And to be honest, using your PC for that, if I was to put a 4090 into it versus integrated graphics, you probably couldn't tell the difference. So in that situation, it is not worth paying all that money for an expensive graphics card. A lot of the CPUs will have integrated graphics in them, and that might be the best thing for you. And then if later on, if you start to use your PC for more graphics intensity tasks or take up a little bit of gaming, you could add a graphics card in. Another thing worth considering here is whether you should get a CPU with integrated graphics or not, even if you are planning on getting a high-end graphics card for gaming, and I would recommend that you do. The reason is, if something goes wrong with your graphics card and you have to send it away to be repaired, and this has happened to me in the past when I built my son's first gaming PC. Just after a month, the graphics card developed a problem. We had to send it away to get repaired, and because we didn't have integrated graphics in the CPU, he had no PC over that month period. I hadn't started YouTube at that stage, and I didn't have a shelf full of parts where I could just drop another one into his system, and I imagine for most of you that's the situation you'd find yourself in. Had we got a CPU with integrated graphics, what we could have done is moved the HDMI DisplayPort cable from the graphics card and plugged it into the motherboard, and then at least we would have had the PC for simple PC tasks like browsing the web and using the computer for work. He would have been able to get his homework on it. But unfortunately at that stage he was stuck without a PC for a month. Now you used to have quite a good choice with CPUs with integrated graphics, and certainly with the Ryzen CPUs, picking one with integrated graphics, you were really sacrificing the CPU performance. It's not currently this way at the moment. The new AMD 7000 series CPUs come with integrated graphics, so if you get one of those, great, you'll have integrated graphics. The Intel ones, you have a bit of a choice about whether you do or don't get integrated graphics. And one of the mistakes I think people would now make is, I'm going to save $20 or £20 by getting the version that doesn't come with the graphics, because I'm not going to need it, I'm going to get a good graphics card. When something happens to your graphics card, that is going to be the best $20 you have spent. So my advice is there's no sacrifice now, it's just that little bit of extra money. There's no sacrifice in CPU performance, so get the one that comes with the integrated graphics if you can. Okay, so you worked out how powerful a graphics card you're going to need. The next thing you're going to need to decide is, do you go with AMD or do you go with NVIDIA? And again, you need to look at what the features each of the platforms is going to give you and decide which you should go for. So again, you're going to have to look at those and look at the benchmarks. For me, when I'm buying a graphics card, I'm buying it mostly for video editing in DaVinci Resolve Studio. And for that purpose, I've always found the NVIDIA cards work better. You could have a less powerful NVIDIA card and a really powerful AMD card, but because with the NVIDIA Studio, the integration and the drivers work so well in DaVinci Resolve Studio, that lower powered card will actually give you better performance than that really high powered AMD card. So that for me is the reason if I'm picking a card, I would go for NVIDIA. But again, your use may be different than mine. So you're going to have to look at the reviews and the benchmarks for what you're planning to use it for, the different features it has to help you decide. They're both really good options. So another thing to point out, if you're going with one of NVIDIA's new 40 series cards, it's going to come with this new 16-pin 12-volt high-power connector, which you're either going to have to have one of the ATX 3.0 power supplies with a special cable coming from it that I've shown you already, or use the adapter that comes in the box with the graphics card with the standard power supply PCIe cables, the 8-pin connectors. And depending on the graphics card you go with, it'll vary between 4 8-pin connectors or 2 8-pin connectors like we've got for this 4070 Ti to connect up. You might have some reservations about going with one of these cards because certainly there has been a number of reports of the cards going on fire. In general, that was cables that weren't plugged in correctly, but I could understand why you might be a little bit wary to go for this. So it's only the latest 40 series cards from NVIDIA that are using this connector. If you go for the latest card from AMD, they're still using the 8-pin connectors that we've been using on the graphics cards for years. So I think this is the new thing. There is a few things you're going to have to be careful with if you're installing it. For example, you're going to want to make sure you plug the cables in correctly into the graphics card and get a nice click. You're not going to want to put a big bend in it. And when you're plugging it into your power supply, if you go with the adapter, this adapter has 2 8-pin connectors in it. It's important you don't just use the one cable from the power supply and then plug in the 2 8-pin cables into the adapter. You need to use 2 separate cables coming from your power supply and just use one 8-pin connector on each of those cables to power the card. So you're spreading the power between the 2 cables to the power supply rather than just the one. It is going to be less of an issue with something like this 4070 Ti, but if you've got the 4090 and you're using less cables, you can have an awful lot of power going through those cables, and that's going to increase the risk of fire. Another thing you may have considered doing is mounting your graphics card in the vertical orientation, because I think we can all agree in this orientation, looking from the front of the case, the graphics card looks really good. In this orientation, you're not getting the best look of it. I think here definitely looks better. Again, that's subjective. There's a few issues with doing this. The first is that you're going to have to buy some additional hardware if it doesn't come with your case. You may need to buy a bracket to mount it in the case because your PCIe slots may be horizontal, and you're almost certainly going to need a riser cable. Because the slot is going to be down here, you need a cable that runs from here up to your motherboard, and that is going to come at an extra cost. So that's one thing to factor in. The other common mistake that you can make is if you get a Gen 3 riser cable, so not a Gen 4 riser cable, a Gen 3 one, and plug your graphics card into it, it might not actually show up when you first plug it in. The reason for that is the Gen 3 riser cable that you're using. To get it to show up, what you would need to do is install your graphics card horizontally, go into your motherboard BIOS, and then adjust the PCIe settings from Gen 4 to Gen 3. And then when you went back and installed the riser cable would work. This is less of an issue nowadays because there's more riser cables about that are Gen 4, and in general the price of them, they're still expensive, but they are coming down. But this was a big issue when the 30 series cards first came out. People were just still using lots of Gen 3 riser cables, and they were building their system and suddenly it wasn't working, and this was a big reason why. So just be careful if you are planning on doing this. You need to be careful for this particular thing. You're better getting a Gen 4 riser cable, I think, if you're planning to mount your graphics card vertically going forward, and this will just avoid this whole issue. The final thing I want to mention about graphics cards before we go on and get this installed in the system is graphics cards are most definitely getting bigger. This is probably one of the smallest 40 series cards that you can get, and I chose it purposely because I wanted to get one that I could fit into the mini ITX systems that I build. But they are really, really big. And in general, if you're putting them into your system, depending on how good your case and motherboard is, you could have a little bit of sag in them. So what you will find is most of these graphics cards are coming with some sort of GPU support bracket nowadays. So the idea of this is there's a little knob here where you can just adjust how high up this goes. And if you put this onto your graphics card, it's going to provide a little bit of support and prevent it from sagging. Like I say, most of the 40 series graphics cards are coming with one of these or another. This one, there's a little screw here which just adjusts how far up this comes. So you put it in the right position for your graphics card and tighten it up. There's other cases that will offer this as part of a standard feature nowadays, and as well some motherboards that will offer a GPU support bracket. If it comes with your case, it's up to you whether you put it in or not. You can set your graphics card and see if there's a lot of sag on it. There is a few downsides. One, it doesn't look quite as good. The big downside, and I have had this happen to me in the past, you have to be really careful on the underside of the graphics card of where you're putting it. And you want to make sure it's well away from the fans. I installed one of these certainly in the last year. It was an absolutely massive card, so I used the manufacturer's bracket, and there wasn't a great straight design on the card. It was really curved, and I had it sitting here, and then at some point it actually moved when the graphics card was spinning up under some thermal testing, and the bracket went into the fan and broke the fan. So if you are using this, this is just one area you want to be really careful with. Look underneath the card and check that it's in a safe position, well away from the fans, because again, that card is one the manufacturer had sent out to me, and I had to explain what happened. If that's your card, you're going to have to send it away and get it repaired, probably at your own cost. We're now ready to install our graphics card, and we're going to need to remove the second and third slot cover from the top. Depending on the thickness of your graphics card, this may vary. So in terms of installing the graphics card, we're generally going to want to install it in the top slot for the fastest speeds. So we're going to need to open the clip in this slot. Asus have a really nice way of doing this. There's a little button over to the side which we can press, and that will open the clip on the slot. The reason this exists is once your graphics card is in place, and say you've got a big air cooler, being able to press the button here can be quite difficult. So actually just being able to open it from all the way over here to remove the graphics card is quite a nice feature. Then we can slide our graphics card into place, and all we're going to do is try and get it lined up with the slot. Just a matter of wiggling it about a little bit till we get it into place. Once we're happy everything's lined up, it's just some firm pressure to the graphics card that we need to apply, and the graphics card is going to clip into place and the slot will close. And then we can secure the graphics card back into place with the two screws we've just removed. Then we can bring our 12-volt high power cable through the cutout at the bottom. We'll go ahead and line it up with the graphics card, and once we're happy things are lined up, we can apply some pressure and it's going to clip into place. We need to be really careful to make sure we've got the cable all the way pushed in. The cards that were going on fire were related to the cable not being properly pushed in, so make sure you get a nice satisfying click when it closes, and make sure that you're not putting any unnecessary pressure when you bring the cable back. So we're not going to try and put a big bend into this cable, we're just going to pull it back down gently towards the bottom of the case. The last thing for us to do is some cable management. So we need to tidy up these cables so we can get the side panel back on again. And you can see one of the reasons I really recommend this case. The cable management solutions at the back of the case are absolutely brilliant. We've got these clips here for managing our EPS cables, and we've got lots of Velcro cable straps over here. So we should be able to get a really clean job done with cable management. So I'm going to take our EPS cables and just push them over behind these clips here, and just work them down towards the bottom of the motherboard. And then we can use the Velcro cable straps here to manage these cables. And then we can just tuck the excess cable that we have left down at the bottom of the case. So that looks nice and tidy. I briefly just plugged this SATA data cable back in. I'm just going to unplug it, and it's going to sit here nicely now. It's managed with the cable, so it's easy enough to plug back in once we've done the Windows install. So hang on there a minute, we're not ready to put the side panel on just yet. If we rewind that back, did you spot the glaring mistake at the back of the case? I'll give you a minute to look closely. Yep, that's it. So the two front fans have become unplugged from the fan hub when we've been doing the cable management. And this is a very real risk when you're managing all those cables. There's a risk that you're going to unplug them either from the motherboard or from the power supply. So whenever you put your PC on and it doesn't work, this may be one of the causes. In this particular case, the two front fans wouldn't have spun up. The RGB cable looks to be connected well, so they would light up but not spin up. So one thing you can do is before you actually manage your cables, you can switch the PC on to check it's working, and then only later on go on to manage the cables. So if you know it stops working after managing the cables, you probably unplugged something. The other lesson here is whenever you're managing your cables, take care not to put excess pressure on them, and it is probably worth a final check to make sure that you haven't loosened any of the cables that you plugged in. And then if there's any plastic protection on the glass, you can go ahead and remove it. Again, I've done a build in this case before, and that's why there's not any here. So we've now reached the most nerve-wracking part of your first build, and that is flipping the power switch and see what happens. Will it actually boot? Now importantly, there is a few places you can go wrong here, and a fairly common mistake is to plug your DisplayPort or HDMI cable into your motherboard rather than your graphics card. So I've got mine plugged into the graphics card, I've got a cable plugged into the power supply and it's turned on. I've got a keyboard, mouse and an Ethernet cable plugged in, and importantly I've plugged a Windows 11 bootable USB drive into the back of the PC. If you don't know how to make one of those, I've made a video on it and you'll find a link to it in the description. So there's no point putting it off any further. We're going to flip the power switch and see what happens. So I'm around the wrong side to see what's going on in the PC, but hopefully we've got lights on and I can hear the fan spinning. So what we're going to need to do is keep an eye on our monitor and see what happens. So this is all fairly normal. It's going to cycle up and down for a little while we're waiting for something to go on the screen with your first boot. So it's just a matter of keeping your patience and seeing what happens. So that's a good sign. We've got the Republic of Gamers logo appearing on the screen. And that's great. We've now got all the information on the screen about our system, and it's telling us to press F1 to enter the setup. And this should take us into the BIOS. So I'm not going to make any changes to the BIOS at this stage. I'm going to come back later on once we've installed Windows. So what I'm going to do is press F10 to save our settings, and then if we press enter, the PC will reboot. And hopefully now this time what it will do is it will find the Windows 11 bootable USB drive in the back of the PC and boot off that, because all the drives that we have in the system at the moment are completely blank. There's no operating system on it, so it can't boot off that. So it's just a matter again of waiting patiently and seeing what happens. So there we go, we're through to the Windows installer screen. What I'm going to do now is show you how to install Windows 11, but to make it a little bit easier for you to see, I'm going to flip over to the screen mode. Okay, so over the next lot of screens, I'm going to pick the options that apply to me. If different options apply to you, pick the ones that are relevant to you. I'm from the United Kingdom, so I'm going to click on Next. I'm going to click on Install Now. And if you've got a Windows product key, you can go ahead and enter it here. If you don't have one, click I don't have a product key. Select the version of Windows you're going to get a product key for in the future. I'm going to select Windows 11 Pro and click Next. We're going to accept the license terms, click Next. We're going to go for custom install, and then all our drives are now showing up here. So you can see why I've unplugged the SATA drive, which is the 500 gigabyte drive, because it would be difficult to tell it apart from drive 0. So this is where we're going to want to install our operating system. So I'm going to select it and click on Next. And this next bit will take a little bit of time, so I'll go ahead and skip through it. Okay, I'm from the United Kingdom. I'm going to click yes. And yes again. I'm going to skip a second keyboard layout. We're going to need to connect to the internet, so I'm going to click on connect and put my details in. We're going to need to name the device. Click next. And then the PC will restart. I'm going to set up for personal use and click next. So we're going to need to sign in to our Microsoft account, so we'll click on the sign in. And then we need to put our details in. If you don't have a Microsoft account, you can go ahead and create one. So I'll put my details in. So I have a lot of previous builds associated with this account. So I'm just going to click on View More Options. And I want to set this up as a new device. I'm going to click on Next. I'm going to need to create a PIN. Click OK. I'm happy with apps using my location. I'll click Yes. I'm happy with Find My Device. Accept. I'm only going to change the required data. Accept. No to inking, no. I'm going to skip all these. I'm going to skip this. I'm going to only save files to this PC. I'm going to decline this. I'm going to decline this. I'm going to click continue. I'm going to decline this as well. And I'm going to skip for now. Okay, so that's us through to Windows, and we're getting a pop-up here asking us do we want to install the Armoury Crate and the LAN drivers, both of which we're going to need. So we're just going to click on yes. We can click on I understand and yes, and then we can click on reopen app. We're going to pull this all the way down to the bottom, click on I agree and click next. Same thing again. And I'm just going to skip the wallpaper and click on cancel. Okay, so we'll come back to the Armoury Crate in a minute because this is where we're going to get our drivers from. But the first thing I like to do is get Windows fully up to date. So we click on the Windows icon, we're going to click on the settings, we're going to click on Windows Update, and we're going to click on check for updates. What's going to happen is Windows is going to find a whole load of updates. It's going to try and install some of them. To install some of them, it's going to need to restart the computer. But we're going to keep coming back here and checking for updates and only move forward when there's no more updates available. Okay, that's Windows fully up to date. Whenever I click on check for updates, there's no further updates available. So the next thing to do is get our drivers installed. So we're going to open the Armoury Crate, which we installed, and then we're going to click on the Tools tab. So we've got the driver tab here. We'll just wait for it to load up. What you'll notice is it's found our chipset driver, AMD graphics driver for the integrated graphics. We've got the Bluetooth driver, the Wi-Fi driver, and the audio drivers. It's also found a LAN driver, but it already installed it. Remember, it did that at the start when the pop-up appeared. So this is a really simple way of installing the drivers. All we need to do is click on Download and Install, click Yes, and then we can go and make a cup of tea and wait while it does all the hard work for us. Okay, so that's all the drivers installed. We can click on Restart Now. Okay, so there's one more driver that we're going to need for our graphics card. So we can either just download the driver, or what I prefer to do is download the GeForce Experience, which will let us keep our drivers up to date. So I'm going to click on Download Now. We can open the file, click on Yes. We're going to agree and install, and then we're going to need to put our login details in. If you don't have an account, you can create one or log in with one of your social media accounts. And I'm just going to click a link in my emails. Okay, so we click on the drivers tab, and if we click here, we can choose which version of the driver we want to install. So there's game ready drivers if you're using your PC mostly for gaming, or studio drivers if you're using it mostly for content creation. So this is going to be a gaming PC, so I'm happy with the game ready drivers, which has already gone ahead and downloaded for me. So I'm going to click on Express Installation, click Yes, and it's going to go ahead and install the drivers for me, and it's normal for the screen to flicker during the driver installation, so when this happens, don't worry. Okay, so that's the drivers installed. We can click on Close and close again. Okay, next thing I want to do is get all our drives to show up, because if we head over to this PC, the only drive that's showing up is our boot drive, which is our 500GB NVMe drive. So to do this, we need to head down to the bottom and type in Disk Management, and Create and Format Hard Drive Partitions will come up. So we'll click on that. And we're going to get a prompt that comes up asking us to initialize the drives. So it's the 3 drives that aren't currently installed. It's fine. We're just going to click on OK. So drive 0 is our 500GB NVMe drive. And what I have found is the drives tend to go in the order. So into M.2 slot 2, we have our team group drive. So we're going to right click here and click New Simple Volume. Click on Next, Next. It's assigned the letter D. If we want to change that, we can. I'm happy with D, so I'm going to click on Next. And then we just need to name the drive. And then click on Next and Finish. The next drive, we can do the same thing. New Simple Volume, Next, Next, Next. And we're just going to name it and click on Next and Finish. And then when the PC was off, I did re-plug in the SATA drive, so it is now showing up as well. So we'll right click on it, click New Simple Volume, Next, 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 and we're going to name it, and click on Next and Finish. Okay, so we now go back over to this PC. You'll notice that all our drives are showing up. So we've got our boot drive, we've got our 2 M.2 drives, and we've got our SATA drive. Okay, next thing I want to do is head over to our motherboards page on ASUS's website. We'll click on the Support tab at the top, and then we click on Drivers and Tools. So we select our motherboard, and then we select our operating system. And over here is the other place you can get the drivers. So for example, if there was something else that wasn't installed at the Armoury Crate at the start, you can go ahead and download it here. If you skipped the step where the pop-up appeared to get the Armoury Crate, you can get it from here as well. The other thing I want to do is head over to the BIOS, but what I want to do is download the latest version of the BIOS before we head there, so in case we've got a chance to update it. So we click on the BIOS and firmware, select our motherboard. So we can see that the latest version of the BIOS is 8.05. So we'll click on download, and then what we want to do is head over to our downloads folder, and then we're going to extract the file, extract all, extract. And then this is actually our BIOS file, so we'll copy it, and I plugged in an external USB drive and we'll paste it onto it. And then we can close this down. So we're now ready to enter the BIOS. To do this, we're going to restart our computer. So we'll click on restart, and whenever the screen goes black, we're going to start pressing the delete key, and this will take us into the BIOS. So it's gone black now, it's starting to press delete key. And that's us into the BIOS. Now taking a look at the version of the BIOS that we have installed, we do have a later version installed on our USB drive. So I'm going to show you how to update it. So what we want to do is head over to the advanced mode. We're going to click on the Tools tab, and then we're going to click on the Flash utility. It's found our USB drive, and here's the latest version of the BIOS that we installed. So we can select it, and we're going to go ahead and click on yes and yes. So it's going to give us a confirmation about do we really want to do it. I'm going to click on yes. And then it's going to start updating the BIOS. Okay, so that's the BIOS updating. A few things about updating the BIOS. You shouldn't really do it unless you really need to, because if something goes wrong during a BIOS update, you can actually brick your motherboard and leave it completely functionless. Reasons for updating it: if your PC is not working well, or the new version of the BIOS offers some function that you need. What's really important is that your PC does not lose power during the BIOS update, because that's a really good way to brick your motherboard. Okay, so that's the BIOS updated. We need to press F1 to run the setup. So that's us back into the BIOS, and we can see we're now running the latest version 0805. And it's a good idea not to make any changes to your BIOS if you're planning to do an update, because when you update it, it tends to be that everything gets reset. So there's a few things for us to change in the BIOS, starting off with our memory. We can see our memory is currently running at 4800 megahertz, but it can run at 5600. So all we need to do is go down here to DOCP and click on Enabled. And you see we've now got 5600 megahertz. Next thing to do is take a look at our fan. So we can see the speed our CPU fan is running at. Chassis fan 1, which is where we've got our fan hub plugged in, and the 2 fans at the front and the 1 fan at the rear. We don't have anything else plugged into any of the fan hubs, and we've got our AIO pump header, and it's running here. So we can click on Q fan control, and this is where we're going to be able to make any adjustments that we want to make. So starting off with our CPU fan, it's currently running on auto detect, but we can change it. It's a 4-pin connector, so it needs to run in PWM mode. So we can click on PWM. So you can see here, it's currently running on the standard fan curve. If we select the silent fan curve, it's going to make a slight change to things. We can click on full speed if we want the fans running at full speed. Or if we want to make our own manual fan curve, we can do that. And then we can drag each of these points to where we want it to be. I'm happy enough with the standard fan curve for our CPU fans. It doesn't sound particularly loud at the moment. Heading over to chassis fan header number 1. So as we've mentioned, it's got a 4-pin connector, so we're okay to run it in PWM mode. And then the last thing that we've got something plugged into is our AIO pump. So it's only got a 3-pin connector, which means it can't run in PWM mode, so we're going to have to run it in DC mode. So we can go ahead and click on DC mode. And I normally do run the pump at full speed. If the noise is particularly bad, I will adjust it. For example, we can click on standard. But I'm happy enough with the pump on full speed. I can barely hear it sitting right beside it. So that would be the way I would normally set the fans up. And then we can click on exit. So I also want to check that our ReSize BAR has been enabled. So I'm just going to click on it and turn it to on. Okay, that's all the changes I want to make to the BIOS. So we're going to click on Save and Exit. It's going to give us a summary of all the things that we have done, and I'm just going to click on OK. And then the PC will reboot into Windows. Okay, so that's us back into Windows. We want to check that the changes we've made in the BIOS have been applied. So we right click on the Windows icon, click on the Task Manager. We'll just maximize it here. And then if we click on the Performance tab, we then click on our memory. And what we can see, we've got the full 32 gigabytes of memory here. And if we check at the speed, it's running at 5600 megahertz. So that's perfect. The memory is running at the correct speed. To check that we've got the resizable bar enabled, we're going to click on the NVIDIA settings, we're going to agree and continue, and we're going to click on the system information, and then we see resizable bar is currently enabled. So we can close this down. Okay, last thing to do is get the RGB set up. So if we head back over to the Armoury crate, so we'll go up to here, we'll click on all apps, and there we go, we've got the Armoury crate here. Okay, so that's us into the Armoury crate. Where we're interested in doing is setting up the RGB, so we need to click on the Aura Sync. So at the moment it has found our motherboard, our memory, and the addressable LED strip, which is the RGB header on the motherboard that we'll plug things into. It's not showing up our graphics card, so we may need to check for updates to see if it appears. So we'll click on the settings, we'll click on the update center, and check for updates. We can see that there's an update for the memory and an update for our graphics card. So let's go ahead and install these. Okay, so hopefully now when we head back to Aura Sync, hopefully the graphics card will now appear. And it's just refreshing. And there we go, we've now got the graphics card. So we're able to set up these devices individually or just sync them all together. I'm happy enough just to change them all together. So we can head over to Aura Effects, and then we can pick whatever we want things to be on. As you look at the case at the moment, you can see everything is currently set to rainbow. But we've got a whole variety of different options. I think I'm probably just going to go with my traditional static white. So let's click on static. And you'll notice everything in the PC at the moment has currently changed to red. I would like it to go to white, so we just need to click on the color. And to get white, we just need to type 255 into each of these boxes. And then click on OK. And you'll notice that everything, the fans at the front, the lighting on the graphics card, the RAM, the AIO, and the motherboard lighting have all turned to white. And this really is one of the big advantages of using the same hardware for your motherboard and your graphics card. It's just going to limit the amount of RGB software that you're going to need to install to control everything. Okay, so that's the PC up and running and looking great. So I think you'll agree the build looks great, and I think the white colour theme that I've gone with the RGB works really well. But there's no point having a PC that looks great if it doesn't perform well, so we'll better take a look at the benchmarks. So in Citybench we had a single core score of 1992 and a multi-core score of 28,835. In TimeSpy we had an overall score of 20,997, with our GPU score outperforming our CPU score. In Unigine Heaven 1080p high we had an average frame rate of 536.7. Moving on to the gaming benchmarks, and all games were tested at a resolution of 3440 by 1440 with graphics settings set to high. Starting off with Shadow of the Tomb Raider with DLSS set to quality, using the game's built-in benchmark with an average frame rate of 201. In Assassin's Creed Valhalla we had an average frame rate of 116. In Fortnite we had an average frame rate of 135. And then finally in Far Cry 6, again using the game's built-in benchmark, we had an average frame rate of 132. In terms of the temperatures when we were gaming, both our CPU and our GPU temperatures were mostly in the 50s, and the highest temperature I've seen on both was 60 degrees. Moving on to a more extreme temperature test, and I did a 10-minute IDA64 stability test with all components in the system being stressed. The maximum CPU temperature recorded during the test was 86 degrees, with our core clock somewhere between 5.2 and 5.3 GHz. The maximum recorded GPU temperature was 65 degrees, and in terms of noise levels, during the IDA64 stability test, the average noise was 54 decibels, while at idle, the average noise was 34 decibels. So, putting everything together, I'm absolutely delighted with this PC. It not only looks great, it runs well, but importantly, it runs cool and quiet. So I can 100% recommend this build guide. And I think I actually forgot how good this case actually is from the time I did my full step-by-step build guide in it. It is absolutely brilliant. Building in it was without any difficulty, and the features, the fans in it are good, they look great and they run quiet, and as well the cable management and the built-in fan hub, it's an absolutely brilliant case and I don't think you could really do better for the price. In terms of putting everything together, following this guide, I don't think you should have any problem. It was one of the easiest PCs I've put together. So if you are contemplating your first PC build, this would be a really easy one to follow. And I think with the steps I've shown, should you want to deviate away with things with a different CPU, maybe a different CPU cooler, or a different graphics card, you shouldn't really have any problems. If you want to go with an older graphics card, all you would need to do is, and don't worry about this 12-volt high power cable, plug in the standard PCIe cables, and you'll be absolutely fine. And I don't really think you should get yourself into trouble if you have to deviate away a little bit. This case does have a whole host of features I didn't get covering today in this build guide, but I have done it previously in my Landco 216 full step-by-step build guide. It's things like installing fans at the bottom, the optional ARGB controller you can mount at the front, moving the I/O module, installing the graphics card vertically, and adjusting the motherboard. So if you do want to do a build in this case and maybe change a few things about, it's probably worth checking out that guide as well. Today I just wanted to focus on a general guide to building a PC for a beginner, which I'm fairly happy with what I've achieved, and the final result I'm absolutely delighted with. Another thing that I really enjoyed using today was this new standing desk that MadeSite have sent out for me. It's their S2 Pro Plus, which is their flagship desk. I'm using one as my main desk behind me as well, and they've sent me a second one for building PCs on. And it is just so much more comfortable sitting here today with the desk up at the right height, and it allowed me to get a lot of angles during the build that I wouldn't be able to get without a desk that went up and down. So a big thank you to MadeSite for sending this out for me. If you do get your PC built and you're wanting to upgrade your desk setup, I can strongly recommend this desk, and I'll put a link to it in the description if you want to check it out. So hopefully you have enjoyed this build guide. If you have, please remember to give it a thumbs up, and if you're not currently subscribed to the channel, please hit the subscribe button as well. Thanks for watching.